In this video, we'll spend a few minutes discussing what MVC is all about and try to clear up the misconceptions that some developers have when it comes to this architectural pattern. You can also take a look at another course of mine on lynda.com called Up and Running with ASP.NET, which contains a video called Understanding the Model View Controller Pattern in the second chapter. It's not a prerequisite for this course, but if at the end of this video you still feel the need for more in the way of high-level explanations, then head over there before continuing on. Since you're watching this course now, I'm going to assume that you're no longer terrified of MVC, if you ever were. But I've found that many developers who have little to no experience with MVC have some views that are somewhat misguided. So here are a few things that MVC is not. MVC is not a completely new way of doing everything. There will be some different ways of thinking about the components of your application, but we're still going to be using HTML, JavaScript, C# or VB, and object-oriented programming. There's nothing magical about MVC in that regard. It's also not too complex to learn in time for your next project. You'll have to put in some extra work at the start to get up and running, but as I just mentioned, we're not going to be learning a new language or an entirely new framework, and the idea is that once you are up and running, it's going to be a lot easier to add new features and maintain your application. Finally, there's an idea in the developer community that some people like to over-engineer systems to show off or to make things harder for other developers to modify. That may be true in some cases, but I can assure you that Microsoft certainly does not want to scare developers away from using ASP.NET, and MVC-powered frameworks like Ruby on Rails would never have become so widely used if they were too complex for people to adopt quickly. MVC was designed to make our lives as developers easier, not more difficult. I've heard some developers say things like, "I hate MVC, it just makes everything too complicated." Most likely, those developers want to stay in their comfort zones because they feel like they can be productive enough without learning new ways of doing things. But if you ask them to show you what their workshop and their tool sets look like for building applications, you might be shown something that feels a little bit like this picture. In this workshop, it's difficult to find what you need, and moving one item will disturb other items or even cause them to break completely. MVC helps us manage complexity through a principle known as separation of concerns. The main concerns are the three letters of MVC: models, the classes that deal with data and encapsulate our business logic; views, the presentation and UI components; and controllers, classes that handle user interaction and manage control flow in your application. So when you apply the principle of separation of concerns, your workshop can start feeling a lot more like this. Things are easy to find, and you have a little breathing room to take out a piece of code and work on it without worrying about disturbing everything else around it. So here are some things to keep in mind about what MVC actually is. It's a useful way to organize code, markup, and control flow logic. It's easy to learn. Again, it's not a new language, just a rearrangement of things you're already familiar with. Especially with ASP.NET, there are plenty of tools and templates to help you get started, and you'll be well on your way to building full-blown applications after watching this course. And remember that MVC exists to help you get your work done and write better software that's easier to test and maintain. So keeping these ideas in mind, in this course, I'm going to be covering the things you need to know in order to be successful when developing applications using ASP.NET. I'll do that by demonstrating how we might implement an ATM cache machine system using MVC principles. One reason I like this project is that it's a system that everyone is already familiar with. The other reason is that I want to get away from the idea that a browser is just requesting web pages, because in MVC, the browser is going to interact with our application more or less by directly invoking methods of a controller class. For instance, methods like withdraw, deposit, view balance, and transfer funds. Before we get started with the ATM, I'll introduce you to this concept of controller actions in the next video. In this video, we'll look at how requests coming into your MVC application are handled by actions, which are methods of a controller class. So I have Visual Studio Express 2013 for web open, and I'm going to choose File, New Project, and then under Visual C#, ASP.NET Web Application. I mentioned in the last video that we're going to be creating an ATM simulation, so I'm going to call this project Automated Teller Machine. I've increased my font size a little bit for you, so let me give this window a little more space. We're going to start with the MVC template naturally. We will be talking about unit testing and security later in this course. I'm just going to click Add Unit Tests now to save us some trouble later on. But I don't need to change the default authentication settings because we will want to set up individual user accounts. We won't be talking about web forms or web API in this course. They're both covered in the up and running course that I mentioned. And once you're comfortable with MVC, you'll have no problem getting started with web API as the core structure is very similar. In fact, web API will actually be merged with MVC in future versions. If you're following along, you should see the Solution Explorer already. I had it auto-hidden. And before we dive in, the first thing I want to do is update all of the NuGet packages that are included in this project template. And I'm going to right-click the solution, since I have two projects, and choose Manage NuGet Packages for Solution. So I'm already looking under Updates, and for what I'm going to show you, I'm most interested in Entity Framework, MVC, and a few others like Bootstrap and ASP.NET Identity. But I'm going to just go ahead and click Update All, and then Accept. And now our packages should be up to date. I'm also going to go ahead and set the main application to the Startup project. We're going to be spending most of our time inside these three folders: Models, Views, and Controllers. Let's start by opening up the Controllers folder. Inside we have two C# controller classes. We'll talk about the account controller soon, but right now I just want to check out the home controller. Because this is the home controller, by convention, any request that starts with /home/ will be handled by one of these methods if an appropriate one can be found. And when we create new controllers, we want to make sure the word controller is in the class name so that we can take advantage of this convention automatically. For instance, I can invoke the index method by making a GET request for /home/index, and likewise about with /home/about. This mapping of requests to action methods is called routing, and we'll be looking at the mechanism that makes that work in the next video. Let's go ahead and add some breakpoints here to verify this. And then I'll hit F5 to start a debugging session. So after my web application starts up, I can see that processing is paused inside the index method. But if I hit F5 again to continue, you can see I'm just requesting the default document for my MVC application. There's nothing after the port number here. That's because the index action of the home controller also happens to be the default action for the entire application. And we'll see where that's set up soon as well, but let me just show you that if I navigate to /home/index, I'm back inside this method here. So what does this method do? Well, we can see that all of the methods in this class return an action result. Action result is an abstract class, and our action methods will be returning a number of different types of objects that all inherit from this class and can be executed in some way to produce a result. It could be just some plain text, could be a file to download, some JSON to process, or some JavaScript to execute. But in this case, it's a view. When we call the view method without any parameters, it's going to go looking for a view whose name matches the name of the method. And because we're in the home controller, by default, it's going to do so in the home subfolder of the views folder. So if I open up index.cshtml, I can see the main part of the markup that's rendered in my browser when I request the index action. The rest of the markup, in the HTML and head and body tags, are in a layout file in the views folder under shared. This is called _layout.cshtml. We'll talk more about exactly what's going on in here and how these two files work together in the next chapter when we take a much closer look at views. Again, if I let this finish processing with F5 and then navigate to, say, /home/about, I land inside the corresponding method. Let me stop debugging with Shift F5 so I can make some changes here. To reinforce the concept of invoking actions rather than always requesting pages or files, Let's add another action method called foo. Right now, if I were to call the view method in my return statement, it would send the view engine searching for a view called foo, which doesn't exist. Let's see what happens. This time I'm going to start without debugging with Control F5. And then I'll navigate to /home/foo. And for once we get a very informative error message. Basically it's saying, I looked everywhere for foo and I couldn't find it. And it's also showing you the order in which it searched for specific items. In this course, all of our views will be CS/HTML files. But if you prefer VB to C#, you can certainly use the VB HTML views. In earlier versions of MVC, we would always use ASPX files for views and ASCX files for partial views. And you can still use them if you want to use web forms instead of the Razor views that we'll be talking more about in the next chapter. So I'll go back to the controller now, and let's say that I don't want to create another view called foo, but I just want foo to be an alias for the about page. I can accomplish that very easily just by passing the string about to the view method. This time, let's just build the project with Control-Shift-B and refresh the page. And now we see the about page. So we've seen how basic requests get mapped to actions of a controller. We've also seen that one of the things that an action method can do is return a view for the browser to render. At this point, you might be wondering about parameters, meaning query string parameters and post parameters. And we'll talk about those in the next video when we take a closer look at how the routing engine works. In this video, we'll take a closer look at how we can configure the mapping of web requests to controller actions, which is known as routing. The ASP.NET routing engine relies on URL patterns to decide which controller action will handle a given request. So far, we've looked at what happens when we request actions of the home controller with home/index or home/about. We could say that these requests match the pattern home/action, where action is the name of the action method of the home controller. To make this even more general, we could also say that they match the pattern controller/action. In this form, controller is the first part of the controller class name. This is more or less the pattern that's set up for us out of the box for the routing engine to use. But in our routing rules, we can certainly add more pieces, or segments as we call them, and one that you'll see already in the project template is an optional ID parameter. For home and about, we didn't need to pass any ID parameter, but later, when we want to look at a user or a transaction or update an account, we might need to pass some information in the URL to identify a specific record. So it's important that the routing engine knows that this parameter is optional, and we'll see how that's configured now. In the root directory of our MVC application, we have a folder called app_start. If we open that up, one of the items we see is a route config class. Let's take a look at this file. The route config class has a single method called register routes. This is called when your application is started, and you can see that if you look at the global application class's application start method. The reason we have this call to ignore route is because any requests with .axt in them are going to be for certain resources or system utilities and will be dealt with by a completely separate handler. The asterisk before pathinfo means that we want to treat the last segment in this URL pattern as a catch-all. That is, we don't just want to match a single token after axt/, but any sequence of characters, even if there are additional slashes in it. Next, we have a call to map route. It's using named parameters to make this easier to read. The route itself has a name of default, it has the URL pattern that we just talked about, and then it specifies a generic object for the defaults parameter that identifies the default values to be used if a controller and an action are not specified according to this pattern. It also indicates that the ID parameter is optional. The map_route method has a number of overloads, but let's set up another simple route using this same one. The purpose of this route will be to identify a URL that someone can use to retrieve the serial number of our ATM. So I'll call the route serial number. I'll be putting the corresponding action in the home controller, but let's say I don't want home to be part of the request path and I just want it to be invoked with /serial. If that's the case, I can just use serial for the URL. But just as an example, let's go ahead and add a parameter that will allow the user to request a different format, like a lowercase serial number. So I'm going to add a lettercase placeholder after serial /, and then in the defaults object, I'll give it home for the controller and serial for the action. And we'll say that the default value for lettercase will be upper. When processing a request, the routing engine will always use the first route it can find that matches. So if we left things the way they are and ran our application and requested /serial, it'll actually try to use the first route, which will match because it has a default value defined for action. And it would look for the index action of the serial controller, which doesn't exist. To avoid a 404 error, we can just move the serial number route above the first route. This will cause it to be chosen first if it matches, and I'll do that just by selecting it and pressing Alt up arrow. Now let's go to the home controller and create this action. So this will take a string parameter called lettercase. I don't want it to return a view because this is something that my application might use internally just to fetch the serial number and display it somewhere. So I'd like to return just a string and not a view or anything more complex than that. First, I'm going to declare a variable called serial and set it equal to a made-up serial number, which will be ASP.NET MVC 5 ATM1. So to return just this string, I'm going to be using the content method. And if lettercase is equal to lower, we're going to be returning content serial to lower. And otherwise, we'll just return content serial. Despite the fact that it doesn't return a view, we can still test this in the browser. Let's use Control F5 to start, and then we'll navigate to /serial. So there's our serial number, and now if I just add a /lower, I get the lowercase version. And because we're not using a view, if you look at the page source, you can see that this string is the only thing in the response body. So this is all fine for GET requests, but when I'm doing a POST request, my parameters aren't going to be part of the URL. So how is that going to work? Well, if a parameter isn't found in a URL segment, it will go ahead and look for it in the query string or POST parameters as well. For example, if we were to remove the lettercase segment here, and we'll remove the default also, and then let's rebuild with Control-Shift-B and refresh the page. It doesn't understand /lower anymore, but if I added a query string and passed lettercase equal to lower, I get the same result. We'll see the real power in this when we set things up so that we can actually pass an object here, like a user or a checking account transaction, and have our POST parameters automatically mapped to properties of that object. For now, we've seen where and how to manage the basic routes for your MVC application. Let's take a closer look now at the different types of action results that can be returned from a controller method. There are a number of classes that inherit from the abstract action result class that we'll want to return at various times from our action methods. By defining the return type of an action as action result, I could choose to return different types in different scenarios in the same method. For example, if I'm feeling a little stingy and I don't want to provide an uppercase version of my serial number, I might return instead an HTTP status code indicating that you're not authorized to see it. Let's look at some of the more common action result types. We have view result, which we've actually been using whenever we call the view method. We use that to render a complete web page along with the associated layout file if there is one. There's partial view result, which we can use to return just a section of a web page. This is very useful for retrieving some HTML during an AJAX request, for example. Or if we wanted to separate a view from its layout for some reason, maybe to embed it in another view, we can use the partial view method instead of the view method. Let's see what happens when we alter the index action and make it return a partial view instead. What we see here is the index view without its layout file, so we're missing everything in the header and footer, including all the CSS and JavaScript. That's not very pretty, so we'll go ahead and revert that change. We've already seen a content result when we returned our ATM serial number. This can be almost anything you want, even a complete HTML document, but typically it's just some plain text or maybe some XML. If you want your action method to return JSON, it's a good idea to use a JSON result, and we would use the JSON method to do that. As an example, we might serialize a new anonymous object with a name and value property with this method. And if you want to test this on your own, for security reasons, we'll need to explicitly allow a GET request here. So we'll just pass JSON request behavior allow GET. That's in case this involves sensitive data that someone could trick me into exposing with a malicious bit of JavaScript. Let's actually do a build with Control-Shift-B in requests/serial. So now I see this as a JSON formatted object. And if you open up Firebug or whatever your favorite browser developer tool is, go to the Net tab and refresh, you can see in the response headers that this is correctly identified as content type application/JSON. Another useful result type is the redirect to route result. You often want to redirect to a totally different action after processing a form, for instance. You may even want to redirect to an action of a different controller altogether. One way to get this result is with the redirect to action method. If I decided that this should no longer be available, I could simply redirect the user to the home page like so. For a complete list of the different types, look at the description of the action result class on the MSDN site. The table toward the bottom will show you the different built-in types as well as the methods you can use to generate them. Using MVC makes it really simple to test all of these different types of responses using just your browser and a little bit of code. So I would certainly encourage you to experiment with these for a deeper understanding. In this video, we'll discuss the use of action selectors. Action selectors are a type of attribute that you can use to decorate your controller methods in order to help the routing engine determine which one to select to serve a request in cases where it might otherwise be unclear. An attribute appears inside square brackets just above a method declaration, such as this one. This attribute indicates that the action method that follows should only be invoked in response to an HTTP POST request. The reason we need to identify this method as a POST method is because we also want to have another method with the same name that responds to GET requests. We want users to be able to request the create action and have a blank form be displayed for them. This action will accomplish that by returning the create view. In practice, however, we usually don't need to explicitly indicate which actions are GET actions. If we create a separate POST version, the routing engine will ignore that one when a GET request for create is made and just choose the method that has no HTTP verb action selector. In the application that we created in the beginning of this chapter, if I navigate to /home/contact or just click the contact link, we get a static page that has an address, a phone number, and some emails. What I want to do is add a very simple contact form here. So let's open up the contact view in Views, Home, Contact, and add a form for someone to use to send us a message. We'll make sure the form's method attribute has a value of post, and by default, this will just post back to the current URL. We'll also add a text area with a name of message, and then a submit button. Now in the home controller, let's look at the contact method. If you're at all like me, this viewbag.message assignment has probably been bothering you because I've been ignoring that so far. The viewbag is a dynamic object that we use to pass information between the controller and the view that doesn't belong in a model since it's not real application data. It's a little bit like a session object, except it's going to be disposed of as soon as your view is rendered, and it's only available if you return a view at the end of your method. If you redirect to another action or do something else, you'll find that whatever viewbag properties you've set will no longer be available. If you need something that would survive a redirect, you can use the temp data dictionary and assign a value for the message key like so. But since viewbag is a dynamic object, I can add properties to it instead of using string keys. For example, I could change message to the message. And let's make this say something more useful, like having trouble, send us a message. Let's go back to the contact view. Here's where viewbag.message is displayed. And remember, we just changed it to the message. And let's move it down here above the form. Now I'll go back to the home controller and create another contact method that uses the HTTP post action selector. This one will take a string parameter called message, and we want to make sure that matches the name of the text area that we added to the form. We'll make a note to actually do something with the message, and for now we'll just change the value of the message to thanks, we got your message. Now let's add some breakpoints to the first lines of both of these methods and start a debugging session with F5, which we'll also save and build. When I click the contact link now, you can see that I'm inside our original contact method. I'll hit F5 to continue, and when I fill out the form and submit, I'm now in the other method that has the HTTP post attribute. And if I hover over the message parameter, I can see what was entered in the form. And this makes it very convenient for me to go ahead and process that however I choose to do so. Hit F5 again, and you can see the success message displayed in the view. There's also an action name attribute that you can use to make your method invocable using an alternate name. For example, let's imagine that you don't like the name about and you wanted to use something else that had hyphens in it. You can't use a method name with hyphens, but you can get around that problem by using the action name attribute. Unfortunately, this will also have the effect of making the view engine look for a view file that matches this string. So we would just need to give it a hint in the view method here to let it know that we're still looking for the about view. One final word about action selectors. With MVC 5, it's now possible to set up your routes with attributes on individual actions instead of using route config. Personally, I still prefer to use the traditional method, but you can use both methods in the same project. So go ahead and Google attribute routing if you're interested in setting that up. So now we've seen how we can conveniently add some constraints and functionality to our methods with action selectors in the form of these simple attributes. Another way you can modify actions in ASP.NET MVC is by using filters. There are several types of filters, and we'll look at some of the more common ones in the order in which they're applied during execution. An authorization filter allows you to specify what users or groups have access to a particular method or controller. One example of an authorization filter is the built-in authorize attribute. The authorize attribute can take several optional parameters, including a list of roles and a list of users who are authorized to execute an action. Notice that we can stack this right on top of our HTTP post action selector. In this example, we're indicating that anyone who has the administrator role is authorized, as well as the user J. Smith, regardless of what roles he or she is assigned. If you just want to require that a user be logged in and deny access to anonymous visitors, use an authorize attribute without parameters. These attributes can also be used to decorate a controller class. In this example, every method in the customer controller would require authentication by default. If you find that there are some exceptions and you need to override that at the action level, you can use the allow anonymous attribute. I just want to mention briefly that in addition to authorization, it's also possible to handle authentication at the controller or action level with an authentication filter, which is new in MVC 5. But we're just going to be focusing on the more common application level authentication when we get to talking about security. Another type of filter is the action filter. And this is where the terminology can sometimes get confusing. It's common for any of these filters to be referred to as an action filter when they are applied as an action method attribute. But technically, an action filter is one that wraps the execution of the body of the action and is applied after authorization filters. So if you need some code to be executed either before an action is executed or after, or at both points, you can create a custom action filter by following these simple steps. Create a class that inherits from the action filter attribute class. Then, override the onActionExecuting method for code that should run just before the action. or the onActionExecuted method for code that should run just after the action. And here's what it would look like. Let's say I wanted to create a filter that would log all successful requests for an action that it's applied to. I would override onActionExecuted to have it run after the action finishes executing. This method is supplied with a filter context object. And one thing I could do is pull out the IP address of the user and pass that to my custom logRequest method. And I would also want to remember to call the base class's onActionExecuted method when I'm done. And then I could just apply this to a given action or to the whole controller using the myLoggingFilter attribute. Notice I don't have to include the word attribute even though it was included in my class name. You can also apply a filter globally to every action in your application. To do that, find the filter config class in the app start folder. Inside the register global filters method, we can add this filter. You'll see that the handle error attribute is registered there already, and we'll talk about that one in a moment. In addition to action filters, we also have result filters, which wrap execution of the actual result of an action. One built-in example is the output cache attribute, and you can do some very powerful things with it, like cache an action result for a specified duration in seconds. Or you could even tell it that a different version should be cached for each parameter value or combination of parameters. So if you have multiple parameters, you can specify a semicolon delimited list there. Finally, we have exception filters, which run when unhandled exceptions are thrown during execution of an action. One built-in example is the handle error attribute. We saw that this is applied in our project template already as a global filter. This attribute is supposed to have the effect of redirecting the user to the error view, which you'll find in Views Shared, and which has access to the relevant error information. Let's see what happens when I change the index method, so the first thing it does is throw a Stack Overflow exception. So let's run this without debugging with Control F5. Now this is definitely not the error view that we just looked at. So what's going on? By default, when a request comes from the same server as the one that the application is running on, it's going to assume that it's safe to show you this detailed error information. So we get what's known as the yellow screen of death, which actually displays some of our code to the end user. If we wanted to see what this looks like for a remote user and not a developer working on the same server, we'll need to go to our web.config and add a custom errors element inside the system.web element. The default mode is remote only, meaning a custom error page for remote users and the detailed yellow screen of death for local users, but we can force the custom error page by setting this to on. And editing web config and saving should cause a restart, so we can just refresh this page and see the error view. Even though this filter is already applied globally, you still might want to apply it to a method or controller in order to specify a different view using the view parameter. And you can also specify different error views for different types of exceptions. In this example, a divide by zero exception would show the math error view, and a Stack Overflow exception would show the SO error view. Any other type of exception would show the error view since it would get picked up by the global handle error filter. This serves as an introduction to the concept of filters in MVC, including some of the most common filters in use today. All of the changes I made to the project are available in the exercise files under Chapter 1 in the Final folder. We'll be taking a closer look at these and other filters later in the course. In this video, I'll give you a quick overview of Razor syntax and explain how you can use it to embed C# logic in your views. For a more general discussion of embedding server-side code in markup and using Razor syntax independently of an MVC application, you can take a look at my lynda.com course Up and Running with ASP.NET, which has a video on Razor syntax in the second chapter. Let's take a look at our index view again. And the point I'm starting from in this video should match the state of the project in the exercise files under Chapter 2 in the Start folder. Now in general, we don't want to have too much logic in our views, since one of the guiding principles of MVC is separation of concerns. But sometimes the easiest way to dynamically display things is with a little bit of embedded C#. So in this file, at the top we can see one way that Razor syntax can be used. We have an @ sign with curly braces, and inside the curly braces we can write C# as if we were inside a .cs file. Here we're setting a value for the viewbag's title property using a normal C# assignment statement ending in a semicolon. Let's look at another type of Razor syntax. At the bottom of the page, we'll emit some dynamic text, say the name of the user's browser. When we have an @ sign immediately followed by C# code, that's going to have the effect of evaluating and rendering it as a string. Request.browser contains a lot of information about the client's browser, but if I just want a human-readable string name, I can do request.browser.browser. And let's save and take a look. You can see that the view engine is pretty smart about where the HTML ends and the C# begins, and vice versa. For example, it doesn't have a problem with the comma right after browser here. It also won't get confused by an email address, which contains an @ sign. A Twitter handle will break things, however. To get around that, we can just use a double @ sign. Another way we can use Razor syntax is by creating inline helper methods to simplify our display logic. We do this with the helper keyword, which allows us to create methods that we can call from another Razor expression or code block. Let's say I wanted to have some logic around how dollar amounts for transactions are formatted. I want negative amounts to be red and everything else to be green. I could create a method called formatAmount that takes a decimal. Inside the method, we'll initialize color to be green, but if the amount is less than 0, we'll change it to red. Then we can simply start typing the HTML that we want this helper method to emit, and we can use an @ sign to switch back to C# when necessary. I'm going to format this as currency for the default culture. Then, anywhere else on the page, even above the helper method declaration, I can call this method. For example, let's first create a generic list of decimal. This is just to have something to test it with, and I'll give it some transaction amounts. The integers can be explicitly cast or implicitly cast as decimals, but for things like 25, 50, we'll want to use the M suffix to make sure they're not treated as doubles. So let's format these amounts in a list with a for each loop. Again, just as easily as I can embed C# in my markup, I can put markup inside these code blocks. And let's take another look. We can simply refresh, no need to compile, and there's our nice formatted list of transaction amounts. Another thing that can confuse the view engine is plain text inside a code block. So you can see that it's treating that as C#. Two ways around that. We can wrap it in text tags, or we can use an @ sign with a colon. You can use normal C# commenting syntax inside Razor code blocks, but if you want to comment out any section of the entire view file, we can use an @ sign followed by an asterisk, and then the reverse at the end. We'll be looking at some other special keywords that we use with Razor views very soon, but for now, we're going to take a closer look at layout files in the next video. In this video, we'll take a look at how the view files that we've seen so far are combined with a layout file to build a complete web page. When the home controller's index action is invoked, it returns a view that corresponds to the name of the action, and its content can be found in the index view file. But obviously, that's only part of the story since we're missing the main structure of our HTML document, including the header and the footer. I mentioned already that the main structure is defined in _layout.cshtml in the shared subfolder of the views folder. But how does the view engine know to find it there? Well, we could tell it that we want to use a certain layout file by setting a value for the layout property at the top of the view file here. We'll make up a name for a layout that doesn't exist to verify this. So we'll save and refresh the home page, and then it complains that it can't find the layout that we specified. By the way, if you see the generic error page, you probably have custom errors turned on from a previous exercise. So go ahead and change that to remote only, or just remove that element from your web.config. So this is one place where I can specify a layout file, and obviously it overrides whatever was already setting it before. So let's comment that out and take a look at viewstart.cshtml in the views folder. The viewstart file is a useful way to apply properties to all of your views. So instead of adding a layout property to each individual view, you can define it once in viewstart as a quick way to apply the same layout file to all views and easily reuse common elements like the header and footer. If you want even more flexibility, you can also add a viewstart folder to any subfolder. And remember that we can still override properties in that file on each individual view if necessary. Let's look at the layout file now. So we'll touch on things like styles.render and scripts.render and the HTML methods, beginning with the next video. For now, I want to draw your attention to the call to render body here. This is where the content in the view file will be injected into the layout. Not everything in the view file has to be inserted there, however. Notice the last thing before the closing body tag is a call to render section. This means that a section of the view file named scripts should be rendered here if it exists. The required parameter is false, so if there's no script section in the view, this will just be ignored. Index doesn't have a script section, but let's see what happens if we add one. And we do that with this syntax. And let's save and refresh, and we'll view the source. And there's our script section down there. Finally, let's do our first little bit of work to customize our application in the layout and the index view. We'll change the title up here to MVC Bank, and we'll change the link text here to MVC Bank, and the copyright in the footer as well. And in the index view, we'll also make a few changes. The MVC actually stands for Middle Valley Community. And Middle Valley Community Bank is a small but pioneering institution with the first ever web-based ATM. And of course, it's powered by ASP.NET. And for the three buttons down here, I'm just going to remove the third one and change the first one so that it says register, and change the link text for the button to register, and the second one will be login. And we'll update the actual links in the next video when we take a closer look at the HTML helper class. Okay, so let's save this and take a look. So that gives you an idea of how you can use layouts to reuse common page elements and render the main content of a view as well as any special sections that it might contain. In this video, we'll take a look at a number of useful HTML helper methods that will improve the readability of our views and also make our code less error-prone. Let's take a look at our layout file again. One common HTML helper is the action link method. The first instance here is to create an anchor tag for a link back to the home page. If I click on the parameters here and press Ctrl-Shift-Space, I can see all of the overloads to this method using the up and down arrows, but the one that's used here was displayed by default. These values represent the link text we want, the action name, the controller name, any additional values or parameters for the route, and the last parameter is an anonymous object containing HTML attributes. Normally, you don't need to prefix the attribute name with an @, but this is here in this case because class is a reserved word in C#. A different overload is used for the next three links. Now, if this just seems like a complicated way to generate anchor tags, remember that your application's URL scheme is sometimes subject to change. For example, an SEO expert might tell you that your URLs have to be entirely reformatted. In that scenario, you would just update your routing configuration, and the action link method would generate the new URLs automatically. And remember that we were going to update these links for register and login in the index view. So actually, we're going to replace the entire anchor tag here and generate action links. The link text will be register, the action name will be register, and these are actions of the account controller. We don't need additional route values or parameters, so that will be null. But let's preserve the CSS class attributes for the button style, and we can do that by passing in an anonymous object with class equal to btn-default, just like the button below. And let's do the same for the login button. So let's save and refresh. And we can see that these buttons are working now. Back in the layout, we see another helper method named partial. We use the partial method to render a given partial view at this position in the document. Click on the parameter and do Ctrl-Shift-Space, and you can see that there are several overloads that allow us to pass data into this view, which we'll learn how to do in the next chapter. Here, we're just specifying that whatever's in the login partial view should be rendered here. Inside that partial view, which is in the shared folder, we see an if-else statement that will cause different elements to be rendered depending on whether or not the user is authenticated. Leaving aside the details of that test right now, let's take a look at the other HTML helper methods here. We have html.beginForm, which will render a form start tag using the specified action, controller, HTTP method, and additional HTML attributes. The using keyword is normally for automatically disposing of objects in memory at the end of a using block. Here, it will also conveniently emit the form end tag /form wherever we put that closing curly brace. The anti-forgery token method will generate a hidden input containing a token that will be validated by the action method that handles this form submission, along with a matching cookie to ensure that any requests for this action actually originate from one of our forms and not from a malicious source. In order for it to be validated, we'll need a filter to do that in our logoff method. Let's open up the account controller and find logoff in this dropdown here. You can see that this action has a validate anti-forgery token attribute, which is an action filter that will check the form and cookie value and reject any requests that don't have a valid token. We'll be looking at many more HTML helpers once we get comfortable working with data. For now, I'll show you one more, and that's html.action. We also use this to render a partial view, but when we need to do so by requesting a controller action and not just rendering the contents of some view. So down here next to the copyright, I may want to add the serial number. And remember, this doesn't have a view, but it does have an action which returns the content for me, and we called that serial. We'll also want to specify the controller name home for context, since this layout can be used from multiple controllers and not necessarily just the home controller. But when I save and refresh the page, I get this error. If we go back to the home controller to the serial method, remember that we were experimenting with action result types, and we set this up to return a redirect result, which doesn't make sense when I'm using it to retrieve content for just a section of a page. So I could switch that back to a content result, or in our call to action in the layout, if we pass a letter case parameter with a value of lower, it'll still return the plain text. To do that, we can use the route values parameter and create an anonymous object and pass a letter case parameter with a value of lower. And then just save and refresh, and we see our serial number in the footer. So that gives you an introduction to the world of HTML helpers. They can take some getting used to if you normally construct all your HTML by hand, but you'll find that they're more efficient and more reliable in many cases. In this video, we'll look at some very useful features for serving JavaScript and CSS files, which are available for all types of ASP.NET projects, and which we'll want to make use of in our MVC application. Let's start by opening up the bootstrap.js file in the scripts folder. Bootstrap is a popular front-end framework used to create responsive web pages, which we'll take a closer look at in the next video. Here we see JavaScript expressions and functions more or less as they were written by a developer. Right underneath that file, we have bootstrap.min.js. This is known as a minified version of the same file. It's functionally equivalent to the first file, but whitespace and line breaks have been removed, and variable names have been shortened, usually to a single letter if possible. Up in the content folder, we have several CSS files. If we look at bootstrap.css and then bootstrap.min, Mosh.css, we see the same kind of transformation. It won't be quite as dramatic with CSS files, since we can't actually change selector names or properties, but by using this and other minified files, we'll get a performance benefit by being able to serve fewer bytes. In general, we'll want to use non-minified files for development and minified files during production to improve performance. So in the layout file, we see several calls to styles.render and scripts.render at the top and the bottom. Each of these will render the link tags or the script tags for a set containing one or more files known as a bundle. The path parameter here is a virtual request path for each bundle. These bundles are defined inside the bundle config class, which is in the app start folder. This class contains the register bundles method. Inside we have multiple calls to bundles.add, which each take an instance of script bundle or style bundle. And these are initialized with a virtual path for the bundle. We also use the include method on this parameter to add one or more JavaScript or CSS files. Notice up here in the jQuery bundle that we're defining the path using a version placeholder. This means that I could replace my jQuery library with a new version and it would still be included as part of this bundle, since the version placeholder acts as a wildcard when combining files to build a bundle. Some of the other paths contain asterisks. The asterisk is a wildcard that can be placed at the beginning or the end of the file name segment of the path. Running in debug mode, this will create a bundle including jQuery.validate.js and jQuery.validate.unobtrusive.js. Files that include VSDoc, IntelliSense, or have the map extension are for debugging purposes only and generally won't be referenced on our web pages. Now, the reason we want to use bundles is not just to group files together and use wildcards. They're also going to allow us to easily switch between minified and non-minified versions of files, depending on whether we're running in debug mode or release mode. Currently, in web.config, under system.web, in the compilation element, we have debug set to true. If we turn that off and we're running in release mode, bundles will also allow us to combine multiple files in a bundle into a single file in order to decrease the total number of requests that the client has to make. This behavior can also be overridden in the bundle config class by setting bundletable.enableOptimizations to true, which is there in our project template already. Let's start off by setting it to false to disable minification and combining of files. And we'll take two examples from our layout file. The first is the style bundle that's being rendered here with the virtual path content/CSS. According to our bundle config setup, this bundle contains two files, bootstrap.css and site.css. With debug set to true and enable optimization set to false, we should expect to see two link elements rendered that correspond to these two CSS files. And although bootstrap.css has a minified version, we won't see that until we set enable optimizations to true. Let's also pay attention to the jQuery bundle. This should just give us a single non-minified file containing whatever version of jQuery appears in this folder. So let's start the site with Control F5 and take a look at the source for the home page now. At the bottom, we have the jQuery file from the jQuery bundle. And at the top, we have two link elements referencing the style sheets from the content/CSS bundle. Now let's go ahead and set enable optimizations to true, and we'll do a build, which we can do with Control-Shift-B or from the Solution Explorer build, and then we'll refresh in Firefox and take a look at the source again. Now we see a single style sheet element, and if we click that, we can see that it's minified. And what actually happened was, because site.css didn't have a minified version, it just went ahead and created one and combined it with Bootstrap's minified CSS file. Note that when a minified file exists, it will be used, and the non-minified file will be ignored, but the minified version will be further minified if possible and will have any comments removed. So at the bottom, we have the jQuery bundle, which just contains the one file again, but a minified version. Notice that there are also version IDs appended to these paths. Those will change when the underlying files change, forcing clients to fetch them from the server instead of going to their caches. Developers who are new to these tools often ask about content delivery networks. For example, if you want to get your jQuery script from Google instead of the local server, click on this parameter for the script bundle and do Control-Shift-Space. And then look at the second overload, which takes a CDN path. So we could add a URL for the minified jQuery script on Google's CDN here. And one other thing we'll have to do is set bundles.useCDN to true. Now if I build with Control-Shift-B, refresh Firefox, and view the source again, down here I should see Google, and I do. But it will still serve it locally when optimizations are disabled. So that should give you some very useful tools to work with when managing scripts and CSS files that will save you some time and improve the performance of your application. In this video, I'll give you a brief overview of what you can rapidly accomplish for your front-end design using the Bootstrap framework. Bootstrap is a wildly popular front-end framework that was developed at Twitter and formerly known as Twitter Bootstrap, but today just goes by the name Bootstrap. At the heart of Bootstrap is a 12-column grid system that we use to organize layouts across multiple types of client devices. We use different CSS class names for each column in a row to specify how many of the 12 available columns we wish to span for each section. In general, we'll make the total columns add up to 12, but for example in the third row pictured here, if we didn't have any content for the 4 columns at the end, we could just remove them without affecting the layout of the first 8 columns. Generally what we'll do is specify that a layout is meant for a certain size device, for example a desktop computer, and then the columns will automatically collapse into a vertical layout for smaller devices, unless we specifically override that behavior with additional CSS classes. The first thing I want to do is go into the index view and remove this Jumbotron section, Jumbotron being itself a Bootstrap class, and then basically start over from scratch here and create a UI that's a little bit more like what we would expect from an ATM, with just several options that can be accessed with some large buttons. If we're going to specify columns for the grid layout, we'll want to start with a div with the row class, so we'll leave that here. Next, I'm going to add 2 columns that each take up half of the available width by specifying that they'll span 6 of the 12 columns. And I can do that with the call-md-6 class. The MD is for medium-sized devices and larger. Let's take a quick look at these class definitions on getbootstrap.com. If I click CSS in the main nav, and then Grid System on the right, followed by Grid Options, I get a handy table that explains these classes. So I just use the call-md-6 class. That means it should span half of the available 12 columns on devices with a viewport width greater than or equal to 992 pixels. Below that, the grid will have a collapsed or vertical layout as it states here. So let's continue with our example. Inside this first column div, I'm going to start adding some buttons. I'm going to create these as anchor tags and then apply some button styles from Bootstrap. And you can read more about these styles under buttons on the same page we just looked at. And we'll fill in the href attribute later as we implement functionality for these options. So first we'll add the base button class, btn, then btn-primary will add some color to it, btn-large to make it a bit bigger, and btn-block to make it a block level element that spans the entire width. And this first button is going to be for the withdrawal option. So let's see what we have so far. Okay, we have a single lonely button up here. And I don't like that it's pushed right up against the nav bar, so let's take care of that. One thing that Bootstrap won't help you with too much is creating vertical space between elements. So I'm going to go into site.css and add my own custom class to add a top margin to any element. I don't want to do this in bootstrap.css because I may upgrade that at some point with NuGet and replace it completely, and then I would lose any changes I made in that file. So we'll apply the margin top 20 class to each column so that when they do collapse, for the mobile view, there'll be some spacing between the two columns. And then one more thing I want to do to make this a little more appealing is add what's known as a glyph. On the Bootstrap site, if I choose components from the top, the first thing I see is an array of glyph icons, and these are built into Bootstrap, and underneath each one is the name of a CSS class that I can use to apply it somewhere and make it appear on my page. But these classes aren't meant for applying to just any element. What we want to do is create an empty span and give it the glyph icon base class, and then the class for whatever glyph we want. And for withdrawal, I'm going to choose glyph icon dash circle arrow down. And let's refresh and take a look. Okay, that's looking a little bit better now. But let's add some more options. I'm going to copy this 2 times, and let's indent that a little bit. And then I'm going to add 2 more options: quick cache, $100, and balance inquiry. And these will have the glyphs flash and question sign. Next, I'm going to copy this entire column, or the inner HTML of it, and then add 3 more options on the right. These will be print statement, transfer funds, and deposit. And then some glyph icons that might be appropriate there are print, transfer, and circle arrow up. So let's save and take a look now. And the last thing I might want to do is add a header image here. We'll do that by adding a row in the layout file. So this will be right above the body, and it will have a column with a class of call md-12. If you're using the exercise files, there's a header image in Chapter 2 inside the Images folder. And since I don't have an Images folder yet, I'm just going to drag this entire Images folder into Content. And once that's there, I can drag logo.ping inside this div. I'm also going to add the img-responsive class to make it scale for different devices, and the center block class to make it a block level element with automatic margins to center it. And now when I refresh, you can see that when I resize, not only does the image scale down nicely, but the buttons stack on top of each other. And that's just so that they can fit the display better. That should give you a good starter set of tools for working with Bootstrap. Take some time to experiment, and then join me for the next chapter on models and data. If you're following along with the exercise files, you can find all of the work we did in this chapter in the final folder inside the Chapter 2 folder. Continuing with our project where we left off at the end of the last chapter, we'll now introduce a model to our application and learn how we can prepare an instance of it with our controller and then pass it to a view. Let's see what the contents of our models folder looks like currently. We have an account view model and an identity model. We'll be discussing these more in upcoming videos, but for now, we're going to create a brand new model class. Right-click the models folder, select Add and New Item, or Control-Shift-A can get you there as well. Under Visual C# and Code, we're going to select Class, and I'm going to call this class Checking Account. We'll keep this very simple for now. I'm going to add some public properties to this class using code snippets. So right-click, choose Insert Snippet, Visual C#, and then look for prop in this list. A quicker way to get there is just to type the word prop and hit Tab twice. So I'm going to have an int ID for a primary key, and then a string for account number, which is a string because it may have leading zeros that are significant. And then we'll add first name, last name, and balance, which will be a decimal. Next, let's add a new controller that we can use to work with the checking account model and pass it to a view. Right-click Controllers, and then Add Controller. Once you add a database, some of these scaffolding controllers will really help you get a head start, like the MVC5 controller with views using Entity Framework. But for now, we'll use one that will just create some stub methods for us, the MVC5 controller with read-write actions. And we'll call it checking account controller. The details action here is going to return a view called details and display information about a user's checking account. For now, we're going to just create an in-memory dummy account, so we'll remove the ID parameter here. If I right-click the action and select Add View, I can add a corresponding view called Details. And if I choose the Details template, I can then give it the checking account as my model class. This will set up some display logic for me automatically. We'll leave data context blank until we have a database set up. We don't need a partial view, and we don't need any script libraries since we're just going to be displaying the data and not doing anything interactive. And we'll keep Use a Layout page checked, but leave the path empty since it's defined in the view start file. If we uncheck Use a Layout page, it will set the layout property to null in the view and we'll lose our layout. Okay, so let's see what's going on inside this view. At the top, we have a very important item, which is the model directive. This indicates that this view is going to work with the model of the checking account type. And anywhere in Razor code where I see model with a capital M, that's going to refer to the checking account model that was passed to this view. You can see more HTML helper methods here, this time of the strongly typed variety, where we're passing in a lambda expression to identify a specific property of the model. Display name 4 returns HTML containing the name of a property, and display 4 returns HTML containing the value of the property. So this view is going to expect to be supplied with an instance of checking account, but we still haven't done anything to give it one yet. Let's go back to our controller and add some code to our action to do that. Again, since we don't have a database set up yet, let's just create an in-memory test account. Control period will help me add the required namespace. We didn't create a constructor for checking account, but we can just specify the initial values like so. An account number with some leading zeros, first name Michael, last name Sullivan, and we'll give it a balance of 500. All we have to do now is pass this as a parameter to the view method. The last thing we'll need to do is update the link for balance inquiry on our home page so that it shows the details page. I've done this for you already, and since there was already a lot going on with this anchor tag, and because it has inner HTML, I didn't convert it to an HTML.actionLink method call like before. I just replaced the href value with the result from a URL helper method called URL.action. It functions in a similar way and can take an action and a controller name, but only returns a URL and not a full anchor element. Let's recompile and start the application with Control F5. And now we can check our balance, at least using this test data. In the next video, we'll take a look at how to alter the display names, since you can see that we don't want them to be exactly the same as the property names. We'll also look at how to create and validate a model using a form. In this video, we'll take a look at how to work with our model properties to get them to display properly on a page, and also how to build effective forms to create new instances of model objects and validate them. Going back to our account details view that we created in the last video, and which we're using for the balance inquiry function, there are a few items to take care of here. I don't need the word details here, and I'll put a space between checking an account. And then at the bottom, I don't need an edit or list link since those are admin functions. So I'm going to remove them. Next, I'm going to turn this into a bootstrap grid by making this a row and then adding a column div inside. I'm going to confine this to 6 columns with the call-md-6 class. And I'm also going to say that I don't want it to start at the first column, but I want it to start after the third column. And I can do that with the call-md-offset-3 class. And let's not forget to add a matching end tag for the div down here. Now for the model properties. By default, the display name for helper method is going to just display the name of the property. but we don't necessarily want to do that in all cases. One solution would be to just replace the razor code with static HTML. But a better solution, and one that we can reuse across views, involves making some adjustments to our checking account model to tell the view engine that we want to display some of these property names in a different way. We're going to do this with the display attribute first. So we'll start with a square bracket above account number and the word display, and then control period to help us resolve this reference. And then we'll use the name parameter and just pass it any name for the label we want. For instance, account with a number sign. To make this easier to read, I like to group the attributes with the properties, and we'll do the same thing for first name and last name. I also might want to create a new property that's just called name and only implements a getter. This will combine the two values, first name and last name, using string.format. Then in the details view, we can remove the two elements for last name and just change first name to name. Finally, we'll make sure the balance is always displayed as currency using the default culture settings. And to do that, we'll use the data type attribute and give it datatype.currency. Let's start the site with Control F5 and take a look. Okay, now we have a decent looking page for balance inquiry. Next, let's build a form for creating a new account. Back in our controller that we generated, we have two create methods, one for displaying the form and one for processing it. Right-click on either of those and choose Add View. This time, choose the Create template and the checking account model class. We also want to choose reference script libraries so that we can take advantage of automatically generated client-side validation with the jQuery validate library. So let's see what gets generated here. This time, instead of helper methods that simply display names and values, we see the label for and editor for methods, which will create appropriate form fields and labels based on the type of property and the additional attributes that we choose to decorate it with. We also see the validation message for method, which will emit HTML containing the client-side validation error messages that can be used with the jQuery validate library. The validation summary at the top can also be used to display client-side validation errors, but we're passing true for exclude property errors, since we'll be displaying those right next to each field instead. This validation summary HTML will still be used if we need to display other general errors that are related to model binding, but not a specific property. And at the bottom, we see that it's going to render the jQuery val bundle, which will drive our client-side validation logic. We don't have a link to this page in our application yet, but Control F5 should start up and take us there as long as we don't have a default start page specified. Right now, if I try to click Create, I get a message saying that balance is required. Even though I haven't set up any validation yet, I'll get this message, since balance is a decimal which can't be null. Let's go back to our model and add some validation attributes. First, above account number, first name, and last name, I'm going to add the required attribute. Then, let's imagine that an account number needs to be between 6 and 10 digits. I might start by using a string length validator, which takes a max length and then optional name parameters, one of which is minimum length. But since I also want to force this to be numeric, a better way to do that would be to use the regular expression validator. I'll use the @ sign to escape the backslash that I'll need for a regular expression that matches between 6 and 10 digits. This time, let's just build with Control-Shift-B and then refresh the browser. You can see now that all 4 fields are required, but if I type an invalid account number, the error message I get is pretty terrible for the average user. To fix that, let's go back to our model and add an error message parameter to the regular expression validator attribute. You can also add this to the required validator or any other validator if you need to change those messages as well. Build again with Control-Shift-B and refresh. And this time you see a much more useful error message. That will give you a good starting point for working with models to develop display and input functionality. Before we start working with a real database, we're going to look at one variation on this pattern, which involves what's known as a view model. In this video, we'll introduce the concept of a view model and talk about how it differs from a typical model in MVC. Let's take another look at the checking account class that we created at the beginning of this chapter. We've seen that we can use this model across multiple pages to display property values of an instance of the model, or to build a form with fields that correspond to each property. Very soon, we'll be persisting instances of this class in a table in a database. Properties of each object instance will generally correspond to columns in that table. This is a typical way to work with models and persisted data, and is similar to patterns in other MVC frameworks like Ruby on Rails. One thing you may have noticed already is that in the main navbar in our application, we have register and login links. The register page shows us a form with email, password, and confirm password fields. And through the magic of Entity Framework, submitting this form will actually create a new database and insert a new user record. We'll be talking about how all that works in the next video, but for now, I want to take a closer look at the register view behind this page in Views, Account, Register. If we look at the model directive at the top of this file, we notice that it doesn't refer to something like account or member, but register view model. The register view model is a model that we use exclusively to deal with the registration form, and not one that will ever be persisted to the database. If we right-click and choose Go to Definition, we see that this is defined inside the Account View Models file. This file contains several view models that are related to user account functions. The register view model contains an email, password, and confirm password property. The confirm password is an example of a property that would never be saved in a database, making it more appropriate for a view model instead of a basic model. The login view model is made up of an email, password, and remember me property to enable cookie-based logins. So here we see two different view models with slightly different properties that are both related to the same database record representing a user. To see how the view model helps create that record, we have to look in the account controller inside the register method. And we want to look at the one that actually processes the form. We can see that the user record that will be created is based not on the register view model instance, but on an instance of another class called application user, which has the email from the view model assigned to its username property. Then, that, along with the password from the view model, which will have to be hashed before being stored, is passed to the user manager's createAsync method. Also, notice the fact that the only parameter to this method is an instance of register view model. The same view model that's used to create the form is used as a parameter to this method and encapsulates all of the post parameters from that form. Let's go ahead now and modify the register view model so that it also includes first name and last name properties and attributes, which we can copy out of the checking account model. Then, in the register view, we can just copy and paste one of these divs twice and change the model properties in these helper methods to first name and last name. And then let's build and refresh the page. And if you do see this yellow screen of death, this is a timing issue. It shouldn't happen if the build is complete like we were told it was. So if you just hit refresh, you should be okay. And there's our updated form based on our updated view model. The checking account model that we created was appropriate for displaying and validating data related to records that we will store in a database very shortly. We've just seen how we might use multiple view models related to the same record for different functions. Before we submit this form, in the next video we'll set up a few more things we need to make sure a user record and a checking account record can be associated and stored in our database using Entity Framework. Using the checking account model that we created at the beginning of this chapter, we'll now see how we can write a small amount of code to associate a user account with a checking account and then automatically generate database tables that reflect that relationship. If you're completely new to Entity Framework and Object Relational Mapping, or ORM in general, you may want to take a look at the third chapter of my Up and Running with ASP.NET course, which will give you an introduction. Back in the account controller, we saw that a new account is created in the register method using an instance of application user. If we right-click and choose Go to Definition, we see that this class is defined in IdentityModels.cs, and it inherits from Identity User. Identity User is the model that's going to be stored in the database and contains properties like username and password hash, and we can add additional properties that we want to store in this inheriting class here. In this file, we also have a definition for application DB context, which inherits from identity DB context, which in turn inherits from DB context. A DB context will serve as the object layer we'll use to communicate with the database. By inheriting from identity DB context, this is already going to give us properties like users and roles, and we can use those to work directly with the user data in our database. The string default connection that's passed to the base class constructor refers to a connection string in web.config that will be used to connect to the database, or to create the database if it doesn't already exist. In our web.config file, under connection strings, we can see that it refers to an instance of SQL Server LocalDB. The data directory token between the pipes represents the app_data folder of our project, where it will create a database file using this file name here. When we eventually do a deployment to a live server, it will be easy to change these settings to use the full version of SQL Server, and we can even maintain separate settings for development and production. So we have all of that out of the box, but what we'd like to add to our application DB context is a member that exposes our checking account data. And we do that by adding a public property that's a generic DB set of checking account, and I'll call that checking accounts. And I'll need to bring system.data.entity into the picture. Again, this is going to allow us to work directly with a checking account table, which we'll be creating shortly in the database. In the checking account class, we'll add another property that will be a reference to the user that holds this account. This will be automatically implemented with a foreign key that references the user table when our database is generated. Making it a virtual property allows it to be overridden by the framework with a mechanism that supports lazy loading of this related object. So we could actually assign a user object to this property and have that be updated in the database. But it's going to be a lot more convenient in some scenarios to just assign a user ID. So we're also going to add the following. An entity framework is going to be smart enough to know, again, that we're talking about the ID property of the related application user entity. Finally, back in the register method, if the creation of the user succeeds, we can set the user up with a new checking account. We'll declare a new instance of application DB context and a checking account. We'll copy the first name and last name from the register view model. And we'll cheat a little on the account number for now just by hard coding it. Balance should be 0 for a brand new account, and we'll assign user.id from the new user that was created to application user ID. Then we just need to add this checking account to the checking accounts DB set and then call save changes. Let's do Control F5 to save, build, and start, and then create a new registration. Notice that I'm logged in now, and I can look for the new database that was created in the app_data folder by clicking the Show All Files button. Double-click it to open it in the Server Explorer. Under Tables, let's look at ASP.NET Users and choose Show Table Data. Pay attention to the ID here. And then checking accounts with the same ID under Application User ID. In this view, we can't tell that Application User ID is a foreign key, but if we choose Open Table Definition, then we can see more complete information. So this is kind of a neat trick, but now that we have an existing database that we've generated from our model classes, making changes to our models and keeping things in sync is going to be slightly more involved. And we'll look at that in the next video on code-first migrations. In this video, We'll talk about how to update the database schema that we created in the last video so it can stay in sync with our model classes using Entity Framework Code First migrations. Let's take a closer look at the checking accounts table that was just created in the Server Explorer. Entity Framework did a nice job of setting up this table given the information it had, but there are a few things I want to adjust now. First, I don't need account number to be nvarchar max. I don't need to support different languages in that column, so I'd rather have a varchar. And we talked about having those numbers be between 6 and 10 digits, so I'd really like to have it be varchar 10. Now, I could just make these changes right here or in SQL Server Management Studio, but we want to create something that's going to be easy to set up in or deploy to another environment. So a better place to make the changes is back in the checking account class. For account number, we've seen now that the regular expression doesn't influence the column type that's created. It's not quite smart enough to use that. I could uncomment this string length validator and leave off the minimum value, but I also want it to use varchar instead of nvarchar. So in this case, I'm going to explicitly set it using the column attribute like so, and use control period to resolve this reference. So I'm going to give it type name is equal to varchar. Be careful not to put varchar 10 there because it won't understand that and you'll get a somewhat cryptic error. Now let's do control F5 to build and start. And because I was already logged in, I get a very useful error message that tells us that things have changed since Entity Framework magically created this database, and unfortunately it can't magically update it for us. But it suggests Code First migrations as a possible solution. So go to Tools in the main menu, NuGet Package Manager, and Package Manager Console. Entity Framework is one of many NuGet packages that we use in an MVC application, and managing migrations is one thing we'll do through the Package Manager Console. The first command that we want to issue is enable-migrations. This takes a context type parameter for which we'll supply our DB context name, application DB context. And now we see that it detected the existing database, and it also created an initial migration in a new folder called migrations. You can think of this as a baseline which it will use to determine what changes will need to be made in the future as we continue to change our models. And in the database, you can see that we have a row in the migrations history table corresponding to this migration, which has been there all along. So even though it didn't actually have to run a migration, this is considered an applied migration at this point. The other part of the highlighted message in the Package Manager console mentioned enabling automatic migrations. And we'll do that momentarily since it makes things a lot easier during these early stages of development when your model classes are frequently changing. But let's see what it looks like to do a manual migration first. We want to push our changes to the account number property constraints to the database. So first, we'll add a migration with the add-migration command. And we'll give it a name like account number changes. It doesn't have to be all one word, but you'll need quotes if there are spaces. And now we get a message about how the migration file will be used and how we can overwrite it if we need to make further changes before applying it. We can also just edit the file that it created directly. The up method is used to apply the changes, and you can see max length 10, Unicode is false because we switched from nvarchar to varchar, and the down method is for rolling them back. We can also create a SQL script if necessary. For example, if we needed to manually apply these updates on a different server. To do that, we would use the update database command with the script flag. So most of this is just values for the migration history table, but at the top you can see the statements for altering the account number column. But if we just want to apply it to the database immediately, we'll use the update database command without the script flag, but we can give it the verbose flag so we can actually take a look at what it's doing. We will talk about what it means by running the seed method later on. It's also possible to roll back to a previous state using the target migration switch with a name of a specific migration. But for now, let me just show you that if we scroll up past this migration history data, we can see that it actually did make the changes here. So we're going to go ahead and try registration now. But before we do that, remember that we had hard-coded the account number in the register method. And now that I know this is going to work, I'm going to go ahead and fix that really quickly. So I'm going to say that account number should be 123456 plus however many checking accounts we have currently in the database. And IntelliSense is a little confused because we don't have an equal sign there. So however many accounts we have currently in the database, which I can get with db.checkingaccounts.count. I'm going to convert that result to a string and then pad it with zeros on the left for a checking account number of 10 digits. And then use that instead of the hard-coded value down here. Obviously, there are some problems with this. 123456 is an arbitrary or magic number, which should be avoided or at least stored in a config file. And if I ever deleted some accounts, I could end up duplicating an account number. But for now, this is good enough for development purposes. So let's go ahead and rebuild and try to register. So that worked, and let's look at the database. And now we see our new checking account with a unique account number associated with a new user. Let's make another change, this time with automatic migrations enabled. So open up configuration.cs in the migrations folder and set automatic migrations enabled to true. Now let's make another small change to checking account. You may have noticed that the application user ID on checking account was created as a nullable column. If I don't want to allow nulls there, I should add a required property, or rather, a required attribute to this property. With automatic migrations enabled, to push this change to the database, all I have to do is run update-database. And we'll give it the verbose flag again. But now, Entity Framework is a little worried about potential data loss. We're offered two ways to deal with this, and we'll use the -force option to tell it that we're not worried right now. So that gives you an idea of what's available to you in terms of keeping your code synced with your database schema with Entity Framework Code First migrations. Remember that all of the code we've looked at in this chapter is available to you in the exercise files in the final folder inside the Chapter 3 folder. Coming up, you'll get some hands-on practice with some of the concepts we've covered so far. So that you can gain some hands-on experience using some of the concepts we've discussed so far, I'm now going to give you a small assignment that involves building out one of our home screen functions. In order to do so, you're going to have to add a new model to our application for a transaction. For now, assume a transaction can represent just one of two things, a deposit or a withdrawal. Furthermore, we can indicate a deposit using a positive amount and a withdrawal using a negative amount. This means that our transaction model only requires the following three properties: an ID, which is just a primary key, an amount, which is the decimal amount of the transaction, and a checking account ID, which is the primary key of the associated checking account. So go ahead and add a transaction model and a transaction controller to our ATM application. Once that's done, create a new view that will allow a logged-in user to make a deposit. And here's one small hint. To get the user ID of the current logged-in user, you can use the following code: user.identity.getUserID. If this isn't valid where you're attempting to use it, make sure you include a using directive for Microsoft.ASP.NET.Identity. You should expect to spend about 20 minutes on this challenge. When you're finished, take a look at my solution in the next video. Good luck. Now I'll show you one possible solution to the challenge I presented in the previous video. I would start off by adding a transaction class to my models folder. I'm going to paste in some properties here, but I'll review them with you. and I'll need to resolve this namespace for the data annotations. So transaction will have an integer ID for a primary key, a decimal amount, and a checking account ID. And that will correspond to a foreign key in the database that identifies the checking account of the logged in user. By also adding this navigation property for the related checking account, Entity Framework will know to set this up as a foreign key. I should also add a navigation property called transactions to checking account. Again, using the virtual keyword enables lazy loading, and it will be an I collection of transaction. We'll name it transactions, and this will allow us to quickly access all the related transactions for a given checking account, doing a join on that foreign key behind the scenes. Next, I'm going to add a transaction controller. I'm just going to go with the empty controller because I know that for now I just want to implement deposit. So I'm going to change this to a deposit action that just returns a view that will show a form with a single text box for entering an amount. I'm going to do a build now with Control-Shift-B so that everything's up to date when we scaffold a view for this action. Once that's done, I can right-click and choose Add View. I'm going to choose the Create template to have a form generated for me. My model class will be Transaction, and data context class should be Application DB Context. You don't have to give this a DB context, but it will add a corresponding DB set to it for transactions if it's not there already. And we'll take a quick peek there in IdentityModel.cs after we add this. And we'll just remove these full namespaces here to make it a bit more readable. One thing we're not going to need in this deposit form is the checking account ID, since we'll be able to look that up based on the authenticated user. So I'm going to remove this entire div with labels and form fields for the checking account ID. Let's go back to the transaction controller and create another action to handle the form submission. This one will need the HTTP post attribute, and it will take an instance of transaction as a parameter. And of course, again, I need to bring in the model's namespace. Next, let's add a private application DB context that I can use from any method in this controller. And then what we'll do is just add the transaction to the transactions DB set and call save changes. Then instead of returning the deposit view again, we'll just redirect to the home screen. The jQuery validation will take care of the problem of users entering invalid amounts, but just in case there's anything funny going on, it's a good idea to verify that the model is valid on the server side as well, and we can do that by checking if model state is valid. And if it's not, we will return the deposit view so that error or validation messages will be displayed. Now, if you're paying close attention, you'll have realized that this isn't going to work yet since we haven't set the checking account ID property of the transaction anywhere. One way to do that might be to set a hidden field somehow in the deposit form, maybe with razor code and html.hidden, and then perhaps pass the checking account ID in with a view model or with the view bag. But an even cleaner way would be to use the query string of the form action, and we can accomplish that just by passing it in as a parameter to the first deposit method. And if this is confusing right now, once we're up and running, I'll explain further. And obviously, in a real-world application, your code should never trust this parameter blindly, as it could be easily tampered with. We might even want to add a filter that checks if the current user has access to this particular account. But using a query string parameter will help illustrate some things about the routing engine, which we'll get to in a moment. Remember that we have a link for deposit in the index view under Home. So let's create the URL and add a query string parameter with url.action. This will be a URL for the deposit view in the transaction controller, and we're going to be passing a query string value using the checking account ID that's already in the view bag, and that's going to be for the checking account ID parameter. Finally, in the index action of the home controller, we can grab the user ID of the logged in user. And remember, I gave you the hint that you'll need to pull in the namespace microsoft.aspnet.identity to make that extension method work. And before I go trying to look up the checking account ID using that user ID, let me declare a DB context property in here as well, again bringing in the model's namespace. Then we can grab the checking account ID from the checking accounts DB set using the where extension method, filtering on application user ID, and then grab the ID of the first and only result there. Finally, we'll add it to the view bag so that our link to the deposit page can be properly constructed. Since we're now relying on a user being logged in to do this on the home page, it would be a good idea to add an authorized filter above indexed. This will force users to go through the login page first. We should also add a controller level authorized attribute to our transaction controller. We'll never let a guest user execute any transaction methods. Before we test all of this, let's update the database to create the transactions table using the Package Manager console. We see that it just applied an automatic migration, so I should be able to build and start the site with Control F5. Since I'm already logged in, I see the home page, and I can also see the query string parameter in the deposit URL. Once I'm on the page, if I view source, you can see that the form action also has the checking account ID query string parameter. And when the form is posted, the runtime will accomplish the neat trick of composing a transaction model using the amount form field as well as this query string parameter. So let's give this a try now. I'll deposit $500 and then open up the database and look at my transactions table. And there is our $500 deposit. Obviously, there are a number of issues we still need to consider, such as updating the balance after each transaction. We'll be talking more about security in the next chapter, and then tackling that issue in the following chapter. In this video, I'll present an introduction to Owen and Katana, two closely related projects that will become increasingly important as ASP.NET continues to evolve. Owen stands for the Open Web Interface for .NET. It's a specification of a standard and not an actual code-based project. The goal of the specification is to decouple web servers and frameworks, specifically to be able to build applications for .NET without relying on IIS or the massive system.web assembly. This potentially allows every component in an application to be modularized and only included in a project as needed to allow for more lightweight applications. It also allows easier migration to other environments beyond IIS or even Windows itself. These ideas are a bit abstract at first, but if you happen to be familiar with the architectural principles of something like Node.js, Rack, or WSGI, then you'll have a good starting point for understanding Owen. Katana, on the other hand, represents an actual implementation of these concepts in the form of a collection of Owen-based components. They include infrastructural components like hosts and servers, as well as functional components such as authentication modules. As a developer, you generally work with Katana by configuring components to be added to the Owen pipeline. The pipeline is made up of a series of components that will handle incoming requests to the application in a certain order, much like HTTP modules in a more traditional ASP.NET application. The components themselves are referred to as middleware since they can receive information from and forward information on to other components. An application using Owen components can be hosted using IIS or with the owenhost.exe assembly, which is included with Katana. It's also fairly easy to design a custom host for these components. Here are the four high-level pieces of a project that makes use of Katana. We have a host, which is responsible for managing the main process of the application, and a server, which is responsible for listening for requests and then forwarding them to the Owen pipeline. If we're just using IIS, then IIS accounts for both of these pieces. Otherwise, it's possible to use two separate replaceable components. As for middleware in the application, the terminology can get a little confusing. For example, the reason that we're talking about Owen and Katana right now is that our MVC application includes an authentication component That's a piece of middleware in the OWIN pipeline. This processes requests and authenticates users before forwarding the request to our main MVC application. However, it's possible today to implement an ASP.NET Web API application or SignalR application using Web API or SignalR as middleware components, independent of any larger application on the other end of the pipeline. And this somewhat blurs the distinction between middleware and the application. If we look in web.config under system.web and authentication, you might be used to seeing this set to forms mode, or perhaps Windows mode if you built some intranet applications before. Here it's set to none because the traditional forms authentication module has been replaced by an OWIN middleware component. So where is that configured? Well, you may have noticed this startup class in the root directory. The configuration method here, which takes an iApp builder, is where all of your OWIN middleware components are going to be registered. Right now, we have a single component for authentication that's configured with the configureAuth method. Right-click and go to definition, and now we're in startup.auth.cs, which is in the app start folder. This defines another part of the startup class and enables cookie-based authentication for users in our application's user store, as well as the user stores of external login providers. In the next video, we'll take a closer look at what's available out of the box for configuring authentication in our MVC application. If you want to learn more about Katana and what kind of components are available, you can visit the project site on Codeplex at katanaproject.codeplex.com. Now let's talk about some of the authentication options that we have with a new ASP.NET MVC application. When we first created our web application, we had an opportunity to change the type of authentication that we wanted to use. If we click the Change Authentication button, here we're provided with 4 options. The first is No Authentication, for when it's acceptable to let any visitor invoke any controller action. Individual user accounts allows users to register with our application and create a new account, or to use an existing account that they have with another provider that supports the OAuth protocol or something similar for third-party logins like Facebook or Twitter. Organizational accounts for accessing company accounts with Active Directory or cloud services, and Windows authentication for basic intranet applications on a specific network. We're going to continue to focus on individual user accounts that will be stored in our local database, and we'll also take a look at how to enable Facebook login as one example of a third-party provider that's quite popular. So let's go back to startup.auth.cs, where the configureAuth method is defined. The first thing that I just want to mention briefly is that we have 2 calls to the app.createPerOWINContext method that create 2 singleton instances that can be reused throughout the application. This OWIN middleware component for authentication represents the first point during a request where the application will reference the database, and it will set up references to our DB context class and the application user manager, which we can reuse later instead of creating new instances of them. These are going to be stored inside the current HTTP context, which is notoriously unavailable at certain times when you need it, but I'll show you at least one place where we can make use of the existing instance of application DB context in an upcoming video. Next, we have a call to use cookie authentication with several options specified. Application cookie is the default authentication type and the one we're currently using. But there are a number of other options, including 2-factor cookie authentication for when you want to set up a 2-step authentication process using phone or email to send codes that a user can verify themselves with. This is also where we can configure the path to the login page to redirect requests from users who haven't yet logged in. So things that you may be used to finding in web.config under the forms authentication settings have now been moved here. For example, I could change the default cookie name here and its security settings. Cookie HTTP only, for example, will determine whether or not JavaScript should have access to this cookie, or if it's for passing with HTTP requests only. I'm logged in right now, so let's take a quick look at the cookies in Firebug. The request verification token is the anti-forgery token that we talked about earlier, and .aspnet.application cookie is my authentication ticket. This stores encrypted information about my user account. Here it is with a slightly bigger font size so that you can see that better. So when I log in or register, my identity is confirmed in the user table that we've already been working with, and I'm issued this cookie, which is validated on subsequent requests. Based on the validate interval, which is set up with the default of 30 minutes, my identity is periodically regenerated by the application user manager, which is connected to the ASP.NET users table. We can also see that by default, we're configuring the authentication component to be able to use cookies for externally stored identities as well, such as the 4 that are commented out below: Microsoft, Twitter, Facebook, and Google. In the next video, we'll take a look at how to properly configure your application to support Facebook login. In this video, we'll implement and test Facebook login for our application. Getting set up for Facebook login is almost as simple as opening up startup.auth.cs and then uncommenting this call to use Facebook authentication down here, which we can do by selecting and then Control-K, Control-U. But just as with any of the supported providers, we'll need to set up an account and an application profile first. If you already have a Facebook account, then it's really easy to get started at developers.facebook.com and start setting up new apps. You'll need to specify a platform for this app. This one will be a website, and then enter a site URL so Facebook knows which domains to allow requests from. I'm still working on localhost, so I'm going to use that. And I'll also need to put that in app domains. And then I'm just going to save changes and copy the app ID and the app secret into my use Facebook authentication method's parameter values. And when we come back here, you can see that I've already inserted those values in this method call. One problem we're going to run into once we are logged in and we get redirected to the home page is that we're not going to have a checking account. That's because we will have bypassed the register method completely. So this code here in the home controller will break. Let's look at the register method in account controller. One thing I'd rather not do is just copy and paste this in the action that handles the Facebook-based registration. You might consider moving it to a checking account controller action and redirecting to that action. After all, it's code that works with the checking account model, and it doesn't really belong in the account controller anyway. But jumping around from action to action while in the middle of registering a user can make for a confusing flow and can also make error handling very tricky. You might also consider adding a method for creating a user to the checking account model. An oft-repeated mantra in MVC is to keep your controllers thin and your models fat. Controllers should contain the bare minimum of business logic, and the remainder should be placed in the model. And while it's perfectly acceptable to add methods here, it seems to me that a checking account shouldn't really be responsible for creating itself. What I would suggest is creating a service class for these kinds of operations that aren't necessarily appropriate for controller actions or models. I'm going to right-click the project and add a new folder that I'll call Services. Inside, I'm going to create a new class called Checking Account Service. Checking Account Service will have a private property of type application DB context, and we'll write a constructor that takes a DB context as a parameter and sets a DB. And we'll pull in that namespace. Finally, we'll write a create checking account method that just takes a first name, a last name, a user ID, and an initial balance. Then we'll copy these lines from the register method, and with a few adjustments, we should have a service method that we can call from wherever we like. So we've already declared DB, and we'll take these values from the parameters passed into this method. Now in the register method, I can replace this code and create a new instance of checking account service. We're going to pass to it the existing DB context that our authentication component already set up using the getOwenContext method of HTTP context. And then we'll use the generic get method with application DB context. And then we'll go ahead and create the account. And let's copy these lines to the clipboard because we're going to be doing something similar with the Facebook login method. When we're finished logging in with Facebook, we'll be invited to choose a username for the MVC Bank app, and then the external login confirmation action is going to handle creating a new user in our system. So let's find that one. The add login async call here will insert a row in the ASP.NET user logins table associating the Facebook user ID with our system's user ID. So let's say that if that succeeds, we'll go ahead and create a checking account for this user. And we'll fudge things a little bit for now by just using Facebook for first name and user for last name. And we're also running a promotion that gives Facebook users $500 for signing up with us. Okay, let's go ahead and restart the site with Control F5. Now on the login page on the right, I see a button for Facebook. I happen to be already logged into Facebook, so I'm immediately asked to give the MVC Bank app some permissions. This default project template oftentimes uses username and email interchangeably, so I can set up a username/email for this site. So now I'm logged in through Facebook, and in the database, I have a user that's just like the other users, except we're not storing a password hash. We can also take a look at the ASP.NET user logins table, which has a new row that associates the MVC Bank user ID with a Facebook user ID. Facebook login is probably not very appropriate for a banking application, but I wanted to show you just how easy it is to set up if you're interested in implementing it for your own web application. In this video, we'll take a closer look at the ASP.NET identity system for managing users. We'll talk about some of the underlying mechanisms and how to customize profile data. An identity is first generated for each user in the register action of the account controller. Here, the user manager creates a user in the database using the form field values, and then inside the sign-in async method, the identity object is created and a cookie containing information about that identity that will serve as an authentication ticket is issued. Notice that the isPersistent parameter is false by default because the user hasn't yet indicated whether they want to enable a cookie-based login on their next visit. It's said that the ASP.NET identity system is claims-based or claims-aware. A claim is just a statement that is made about a user by an identity provider. The value of an email address or a username or role assignments can all be thought of as claims. One slightly confusing point is that those three things I just mentioned are stored in the ASP.NET users table and the ASP.NET user roles table. But then we have another table called ASP.NET user claims. This can be used to store additional custom properties. But all of these things should be thought of as claims, and all of them will be stored in the authentication cookie that we looked at earlier. Back in the register method now, let's imagine that we wanted to store the user's first name as a claim in our cookie so that we can add it to the header of the site without getting it from the database with every page load. In the register method, once our user is created, we can use usermanager.addClaim and pass the user ID and a new claim. You can use the built-in claim types or a custom string for the name of the claim. If we use the built-in strongly typed claims, for example, I can use given name, and we're less likely to make an error. And if we ever transmit this information to another website, they're more likely to be able to interpret it correctly, since these correspond to full schema URLs, and for the value, we'll just use model.firstname. We'll add the name to the header in login partial. And we'll need to bring in another namespace, system.security.claims. And then if the request is authenticated, we'll cast user.identity as a claims identity. This gives us access to a number of useful methods, like findFirstValue, which takes a claim type and will give it given name, which is the one we set up. There's also a method called hasClaim to check for the existence of a claim of a certain type, but we could also just check to see if it's null and fall back on the username. Then, instead of displaying the username here, we'll just change it to name. So let's give this a try with Control F5, and we'll do a new registration. And once we're registered, I now see hello Mike instead of my username or email. Let's take a look at the claims table. And there's our given name value for that user ID, which will be stored in the cookie each time it's generated. Another way of adding additional information to the identity object is by adding properties to the application user class. These will be persisted to the database. For example, if you decided you wanted every user to have a PIN for additional security, we could add a PIN property here. Don't forget the getter and setter, otherwise, when we go to the package manager console and run update database to add this as a new column, nothing will happen. For a really quick demo of how to access these custom properties, let me just open up the database and manually set a PIN for the user that I just created. And then in the index view, let's just try to display it on the page using the view bag. And obviously we'll have to add it to the view bag before we can display it. And we'll do that in the index action in the home controller. And this part is a little bit cumbersome because unfortunately it's not added to my identity object automatically, but I have to go and get an application user object from the user manager. So I'm going to get the Owen context. And this time, instead of the get method, I can use get user manager. And to make this work, we'll need to add microsoft.aspnet.identity.owen. Then we'll use the findById method and pass the current user's ID. And finally, we can add the user's PIN to the view bag. And now let's do a build and refresh. And there's our PIN down here. So I've tried to give you a good introduction to the new ASP.NET identity system and what you can take advantage of out of the box for managing your users. In the next video, we'll talk about how to restrict access to controller actions based on a user's assigned roles. In this video, we'll set up some admin-level functionality and use role-based authorization filters to control access to it. In our checking account controller, we haven't yet applied any security filters. Remember that we can apply an authorization filter in the form of an authorized attribute at the controller level to require a user to be logged in order to execute any action in this controller. Right now, our only real action just displays details for a dummy account. Let's alter this so that it shows the details of the logged in user's account. In a moment, we'll add another method here, so let's declare a private application DB context that any method can use. In the details action, we'll keep the return statement, but let's get the checking account from the DB set. First, we'll grab the user ID of the logged in user, and if you're following along and that's not valid for you, make sure that you have the Microsoft.ASP.NET.Identity namespace. Then, instead of returning this dummy account, we can filter on the actual checking accounts DB set with the where method, and we'll be filtering on application user ID, and we'll take the first result. So now, a user is prevented from just changing the checking account ID to view the details of any account. But let's imagine that we want to have another action for an admin user so that they can view the balance for any account by passing any checking account ID. In order for them to easily access any account, we'll build a view that lists all existing accounts, which is returned by an action that we'll call list. So this will return a view, and we'll just pass to it all the checking accounts in the system with db.checkingaccounts.toList. Right-click the list method and choose Add View, and then the list template and checking account for model. We don't need script libraries since this will just be a static display. And notice that when this is created, the model directive now shows an IEnumerable of checking account instead of just a single checking account. And then, instead of just displaying properties for a single model, it's doing so in a for each loop that displays details for all accounts. Remember that the details action that's linked to here only shows the current user's account, even if we pass in a checking account ID, which will be ignored. What we'll need to do is create a new action, and let's call that action details for admin. And now in the controller, we'll just make a copy of details. We'll name it details for admin. It will take an integer ID parameter to identify a checking account. And we can get that checking account with just the find method on the checking accounts DB set. We're also going to explicitly pass in the name of a view, which is details. And we can reuse that one instead of creating a brand new view called details for admin. We're also going to decorate this action and the list action with the authorize attribute. And we'll say that these are only to be accessed by users who have the admin role. So we still have to create the admin role, and we'll do that and assign an admin user to it in the next video. Continuing where we left off in the last video, let's talk about some quick ways to get some roles set up in your database and assigned to users so that we can test our admin functionality. An easy way to get some roles and user role assignments into your development database is to use the code first migration seed method in the configuration class in the migrations folder. Conveniently, this method is supplied with an instance of application DB context, so that we can easily create an admin user and an admin role and assign the user to that role. We're going to spin up an instance of a user manager. To do that, we first need to create an instance of a user store, and we'll be specifying the application user class and passing it the DB context. And we'll need to pull in a few namespaces in order to do this. Once we have the user store, we can create a user manager by again specifying the application user class and passing in the store that we just created. So now we can work with a DB context directly or a user manager, both of which can access the users table in different ways. We might also want to create a role manager, but to keep this a little simpler for now, I'm going to be accessing the roles DB set directly with the DB context. Since this seed method is going to be executed every time we issue the update database command, we'll want to be using methods like add or update. These will check for existing records instead of the usual add, which does not. Or if we just wanted to use the usermanager.create method, which can take a plain text password, we might want to test for an existing user first using the any method of dbset. So we could say, if not context.users.any, and then pass a lambda expression to tell it to test for an existing user by username, and we'll tell it to test for an existing user with the username admin@mvcatm.com. If there isn't a user with that username, we can go ahead and declare a new user, and we'll want to set both username and email. As I mentioned, in the project template, the login view asks for email, but then it passes it as username, so it assumes that they're always going to be the same. This can be a little bit annoying, but you can certainly change that on your own now. So once we have the user, we'll call usermanager.create and pass it in along with a plain text password. It will need to pass the validation, so you'll need at least one capital letter, one number, and then one non-alphanumeric character. This will create the user instantly. There's no need to explicitly save any changes. Once we've created the user, remember that we'll want to set them up with a checking account using our checking account service. The checking account service constructor takes a DB context, so we'll just pass along the one that we have already. So we'll just use admin user for name, pass the new user ID, and we'll say that this account has an initial balance of $1,000. Now to create the admin role, I'm going to call add or update on the roles DB set and give it a new identity role called admin. This lambda expression here tells it to look for an existing record using the name property. So that I'm able to add my new user to this role, I'm first going to have to call save changes. so that the role exists in the database. And finally, I can use the user manager's add to role method to assign my new user to the admin role. Let's go ahead now and run the update database command and test this. So it says that it ran the seed method. And let's go over to the list view and then do Control F5 to build and try to view this page immediately. Notice that even though I'm logged in already, it's taking me to the login page since I don't have access to the list page. So let's go ahead and log in with the new admin account that we just created. And you can see that I get a list of the accounts in the system. A lot of the links on this page are for actions that haven't been implemented yet, but if I click Details, I can view the balance for any account. So as you can see, using role-based authorization on a controller action is fairly simple once you have some roles and assignments set up in your database. The principle of separation of concerns and the organization of controller logic into individual actions makes MVC ideal for unit testing your code. In this video, I'll give you a basic introduction to the main concepts behind unit testing. Many uninitiated developers and managers think that unit testing is just a fancy term for testing, and they won't bother to ask what we mean by a unit. If you do ask, though, you might get many different answers. Some will say a unit is a class or perhaps a group of related classes. Others will tell you that it makes sense to think of a method or a function as a unit. Other, more vague definitions might include a little bit of code, or the smallest piece of code that it makes sense to test. So there really is no exact definition, but what I can tell you is that a single unit test shouldn't be responsible for testing an entire class that contains a lot of code. The unit tests themselves should be short and sweet, and should test small bits of logic in isolation. So even if you like to think of a class or a module as a unit, you'll need many small tests for that unit to achieve what we call good code coverage. So what are the ideas and the goals behind testing small pieces of code? It's notoriously hard to convince a developer that he or she should practice unit testing because it sounds very time-consuming and it can feel like examining grains of sand when what you really need to do is sprint across the beach to meet a deadline. You'll need to experience the benefits firsthand to really appreciate it, but I'll try to give you an idea of why you should be doing it. One reason is just to confirm that your code works the way you expect it to. This is often not the case, and the idea is that instead of doing a lot of debugging later on, you can catch more mistakes in the early stages while you're first writing the code. Second is to help determine when code that you write is complete. Writing tests along with new code helps you better understand the criteria for success or completion of a module or a function, for example. Another goal or benefit is that it makes changing the code less scary. When we make a big change to a project, it's still possible that we might break something, but we'll feel a little more secure knowing that we've created tests that can easily detect many problems that we might cause by doing so. Let's say that you do make a big change to a project and suddenly all your unit tests are failing. You can go through them one by one and fix the associated code. While you're doing so, you can get up and walk away and come back later, and just by running the tests again, you can see exactly what you should fix next. Tests can also help us document our code. A well-written test should be clear in its purpose and should communicate to a reader what we wanted the code to accomplish. A unit test in ASP.NET is normally a method with a void return type that follows the arrange, act, assert procedure. In the arrange step, we prepare the items that we wish to use during the test. Here, we're testing that a method used to switch to the secure HTTPS protocol works as expected, and we'll be testing with the URL declared in the arrange step. In the act step, we run the URL through the makeSecureURL method, and then in the assert step, we test to see if the result is the expected one. We'll be using this assert class from Visual Studio's built-in testing tools. And the r=equal method shown here doesn't return anything, but will actually throw an exception if the two objects are not equal, which is how we'll know that the test has failed. A better test would examine multiple URLs, so it's perfectly fine to have multiple assert statements in your test. We want to know if any of them throw exceptions and then we can fix them one by one if necessary. So now that I've convinced you that unit testing is absolutely, positively worthwhile, what else do you need to get started? Well, you'll need to create a class to store all of your test methods. And we'll also need some testing tools or a test framework to actually run the tests and report on the results. We'll be using the Visual Studio unit testing framework, and just like in many unit testing frameworks, we'll be seeing green and red for passing and failing tests. So that's the general idea behind unit testing. In the next video, we'll get started with writing and running some actual tests. In this video, I'll show you how to get set up with the Visual Studio unit testing framework and start writing some tests for your code. The unit test project that we added at the beginning of the course includes a folder called Controllers, with a home controller test class for testing actions of the home controller. If you're going to really get into unit testing, this is a good way to organize your test code, mirroring the structure of the main project with potentially many different test classes. For now, I'm going to remove that folder and start from scratch and just add a new test class by clicking on the project, pressing Ctrl-Shift-A, and selecting Basic Unit Test. And we can keep that default name. Inside, we see a shell of a class with a single method. Notice the test class and test method attributes that decorate the class and the method. When we decide to run our unit tests, the unit testing framework will look for all test classes and test methods in the project that have those attributes. This test here doesn't do anything yet, but it also doesn't throw an exception, so it will pass. In the main menu, there's a test menu where you can choose to run all tests or a subset of the tests. You can also right-click here in this file and choose Run Tests. And then in the Test Explorer, which I'm just going to move over here, we get a list of past tests. Failed tests would appear here too if there were any. So let's write our first real test now. If you remember back in Chapter 1, we had a foo action in the home controller that returned the About view. One thing some developers like to test in MVC is whether or not an action returns the correct view. Others find it to be a waste of time and think that they'll never change anything that would break such basic functionality, but it really can't hurt, and it will serve as a good example of how we might work with a controller inside of a unit test. So I'm going to change the name of this method to foo action returns About view. I'm using a name that makes it very obvious what we're trying to test here. We want some other developer who might be maintaining this code later on to understand exactly what we're doing. So these method names will serve as some documentation for both the tests and the main code itself. And using these rather long method names is perfectly okay since it isn't going to clutter up any client code elsewhere. So I'm going to instantiate a home controller, which will be my arrange step. And then for my act step, I'll just call the foo method and cast the result as a view result so that I can check the view name property. And you can see that as I'm writing this, I'm pulling in the namespaces that are missing. Then I'll assert that the string about is equal to the view name. Before we start testing, let's add one more test. This one is going to test that a message is placed in the view bag that says thanks whenever someone submits the contact form. So we'll write a similar test, and we'll call the contact form method the second overload that takes a message parameter and just pass any string we want. And then I want to make sure that the view bag message is equal to the string thanks. And we'll need to remember to cast this as a view result like we did in the first test so that we can access the view bag. And this one is an example of a test that's very specific and whose primary purpose is just to prevent someone from changing this message in the future. Now if I right-click and choose Run Tests again, I can see that the foo test passed, but the contact form test didn't. And if I click it, I can see exactly why. Because there was a little more to this message than I thought. And maybe I decide that this test is actually a little silly, but it would be nice to ensure that there is some message there. So maybe I'll change it to use the isNotNull method and just pass the message. And we can run that test again by opening up the Test Explorer and choosing Run Failed Tests, and everything passes. One thing I should mention is that the view name of the view result is only going to be set when it's passed explicitly to the view method, as it was in this action. If you wanted to do the same test with the contact action, for example, you'd have to explicitly pass the view name here, otherwise the test would fail. Tests should be lightweight and fast, and should not rely on dependencies such as databases. For example, if I were to test the deposit action in the transaction controller in its current state, that test would be more accurately called an integration test, since I'd be testing not only a unit now, but the integration of that unit with another component. I've shown you some of the simplest types of unit tests already, and in the next video, we'll talk about how to mock a dependency, like a database, so that we can continue testing our code in isolation. In this video, I'll introduce the concept of mocking and demonstrate how we can create a simple mock database context so that we can quickly write and execute tests using any in-memory test data that we wish to construct on the fly. We're going to be looking at how to test the deposit method in the transaction controller. Now, when I write tests, I don't want to have to think about what's currently in the database and what checking account ID to use. It would be a lot nicer if I could just whip up some fake data using some in-memory objects to test this code. That way, the test will work regardless of the environment and the database. In order to do that, I'm going to make some changes to this controller's understanding of what the DB member is that we defined up here. Instead of telling it that DB is going to be an instance of application DB context, I'm going to tell it that it'll just be an instance of some class that implements an interface called iApplication DB context. This may connect to real data in a database or fake in-memory data, and we'll define that interface in a moment. And I'm not going to assign it here anymore because I'm going to create two constructors that will handle that assignment. One for normal use by our application and one that we'll use for testing purposes. So once we have everything set up, we'll be able to instantiate a transaction controller and pass it a mock version of the DB context using this constructor. So there are a couple of things we have to fix. First, we need to define our interface. And second, we need to make sure that our existing application DB context implements the interface. I want to first go ahead and move application DB context, which is inside of identitymodels.cs, into its own file, because it doesn't really make sense here anymore since it deals with identities as well as checking accounts and transactions. So I'm just going to create a new class called application DB context and paste that code inside. And we'll just need to bring in a few namespaces. And then I'm going to define the interface in this file as well. Just like in our real DB context that will implement this interface, we're going to want members with the names checking accounts and transactions. However, if we define them as DB sets, we're going to have the same problem with being tied to the database when we really want to stay disconnected. If you dig into the definitions a little bit, you'll find that DBSet already implements an interface called IDBSet, which we can use instead to define these members without having to commit to using a database. And for now, we can get away with just adding a save changes method, since it's the only thing we call directly on the DB object in our code. Lastly, we'll want to change these members down here to be IDBSet. And then we should be able to say that application DB context implements iApplication DB context. And actually, I wanted this interface inside this file in this namespace, but not inside the class. So I'm going to move that up here. And again, now we should be able to say that application DB context implements iApplication DB context. Now let's go ahead and create an implementation of the fake DB context. So this is going to look very much like our interface, except we're going to have to implement save changes since it's used in our code. This will also implement iApplication DB context. And we'll copy these members and then implement save changes. We're going to be implementing these fake DB sets as lists. So when we use the add method on the checking account set, for example, that will be sufficient for simulating the creation of a new checking account. So we can just return an int in save changes without doing any real work here. The last thing we'll need is a fake DB set that works with an in-memory list instead of with the database. To correctly implement IDB set, you'll need to define many different members. You can find a lot of implementations of IDB set online in various blog posts and repositories. Here's one from GitHub Gist, which is for storing and sharing snippets and small pieces of code. So I'm going to go ahead and click the raw button and then copy all of this text and then add a new class called fakeDBSet. But instead of this namespace, I'm going to give it the same namespace I've been using for my models, automated teller machines, machine.models. And notice for methods like add and remove that it's just using an in-memory list, a generic list that's initialized when the instance is created. Now that we've done all of that work, we can finally start to write some tests using our fakeDB context. Let's say we wanted to write a more useful test that checks whether or not an account's balance is correct after a deposit is made. For my arrange step, I can create a fakeDB context and initialize the checking accounts property as a new fakeDB set. Then I can create a new checking account and give it an ID and an account number of my choosing. And then I'll just add it to the checking account set. Obviously, this test is not finished yet. I still have to actually execute the controller method and see what happens to the balance. But you've seen now how we can mock a dependency like a database in order to test our code. In the next video, we'll finish this test and add some new logic to our application to ensure that it passes while we discuss test-driven development. In this video, I'm going to give you an introduction to the practice of test-driven development while we build an important missing piece of our ATM system. The basic test-driven development, or TDD, process starts with creating a test that's a failing test. It fails because we haven't yet written the code to make it work. We also want to be able to observe it changing from a failing test to a passing test as an indication that we've accomplished something. Next, we make the test pass in the simplest way possible so that we get the basic structure of the test and we verify that our assertion statement makes sense. Finally, we refactor the code to solve the problem in a more elegant or efficient way in the general case and make sure that the test still passes. You'll hear this process referred to as red-green refactor. Let's continue now with the test we were writing in the previous video to check for a correct balance after a deposit. The next thing we need to do is to set the fakeDB transactions property to an instance of fakeDBSet of transaction. And then we'll declare a new instance of a transaction controller and pass it the fakeDB to use in its constructor. Again, this is going to allow us to test the deposit action without involving the real database. Finally, we'll call the deposit action, passing a new transaction, and being sure to set the checking account ID property to the same value that we used for the ID when we created the checking account. And I'm just going to go ahead and group these a little differently. In the beginning, we have our arrange statements. Our ACK statement consists of the actual deposit. And then for assert, we can go ahead and try to assert that the checking account's balance is now 25. Before we run the test, one thing we'll have to add is a reference to Entity Framework so that this project can correctly resolve these fake DB sets as IDB sets. So let's grab that with NuGet for our test project. Right-click References, Manage NuGet Packages, and then switch to Online on the left and install Entity Framework. Now let's just right-click and run tests. And now we get our red test because we haven't yet written any code to update the account balance. But remember, before we do that, the next step is to make the test pass in the simplest way possible. Taken to an extreme, one solution would be to just change checking account.balance to 25. That's probably not going to help us along very much. A slightly better green test would be to leave the assert statement as is and set checking account.balance equal to 25 here. Again, this isn't going to move things forward very much either, but in a more complicated example, Performing this step is going to help us verify that our assert statement is valid. So let's go back to the Test Explorer window now and select Run Failed Tests. And now we see that it passes, but we still don't have a real solution yet. So let's take a look at our transaction controller. What we want to have happen is, as soon as this transaction is added, the balance of the associated checking account should be updated. This might be a good job for our checking account service. Let's add a method here called updateBalance that takes a checking account ID. First, we'll get the checking account in question. And because my fake DB set doesn't actually implement find, I'm going to use where and then take the first result. And I just want the ID property of the checking account to be the checking account ID that was passed in. And then I'm going to take the first result. Next, I'll update the account balance, and I'll set it to the sum of all transactions that are for that checking account ID. This will work because, remember, we represent both deposits and withdrawals in the same way, just with positive and negative decimals. So again, we're going to filter with where, and then use the sum extension method for amount. And I'm not going to use the transactions navigation property to make this code simpler, because it's not going to be set up for my fake DB set. And don't forget to call db.savechanges. Right now, checking account service doesn't use an iApplication context, so let's fix that and also change the constructor so that it takes one. And then back in the transaction controller, we can create a new service and call updateBalance. And we'll be passing in the checking account ID of this transaction. And let's not forget to pass our DB, whether it's a real DB context or a fake one, to the checking account service constructor. Back in the test, let's remove this hard-coded balance and run the test again to see if we can get our green test with refactored code. So I did repeat last run. You can also do run all, and you'll see that all of our tests pass. Before we wrap up, I should say a few things about our whole approach here. First, if this seems difficult, tedious, or limited in certain ways, that's completely understandable. We just did a lot of manual work in order to help demonstrate the fundamentals. But there are a number of tools and frameworks out there that can simplify things. There are complete frameworks to help you mock objects, such as RhinoMocks, or mock spelled MOQ, to help you deal with creating mock implementations for dependencies. There are also dependency injection containers, like Castle Windsor or Ninject, which can handle instantiating your controllers with the correct type of DB contexts and other dependencies, and make it easy to toggle between the fake and real versions of objects throughout your application. So that's the basic process that we use for test-driven development, and I think that you'll find that if you put it into practice, it will really help you think through problems and arrive at stronger solutions. Again, all of the code that we worked on in this chapter is available in the exercise files in the final folder under Chapter 6. In this video, I'll show you how to use AJAX requests with actions to update sections of a page without having the browser load an entire HTML document. We're going to look at two ways of doing this, and the first one is ideal for developers who don't have a strong handle on JavaScript. What we're going to do is make a few changes to our contact form so that it makes an AJAX request when we post it and updates just the message in the form here, instead of refreshing the entire page like it's doing now. The first thing I'll want to do in the contact view is remove the form tags and replace them with the using block. But instead of html.beginForm, I'm going to use ajax.beginForm. This has similar overloads to html.beginForm, but the one I need now just takes an instance of AJAX options. And the options I want for now are HTTP method, that's going to be post, and insertion mode, which tells it where we want the response to be included in the page. Do we want it after a certain element, before a certain element, or to use it to replace a certain element? I'm going to use replace, and I'll explain the difference between replace and replace with in a moment. And what are we going to be replacing then? We specify that with the update target ID property, and I'm going to give it form section. This will be a new div that wraps this entire form as well as the message. And I just need a curly brace here, and instead of the form end tag, a closing curly brace. And I'll remove that extra div end tag there. And if I want to indent this, I can just do Control K, Control D. So the difference between insertion mode replace and insertion mode replace with is that the first will replace everything inside this div, and the second will replace the entire div itself. Using ajax.begin form requires jQuery, which is already pulled in with a bundle in the layout file, but it also requires a script that we'll need to get with NuGet, and this is called Microsoft jQuery Unobtrusive Ajax. And we'll see why it's called unobtrusive once we're up and running. You can find this by searching for MS Ajax, and it's the second result here. So this should be under scripts now. And to make it appear after the jQuery bundle, we'll need to add a script section here. And then I'll add the minified version by just dragging it in from the Solution Explorer. And now there's really just one more thing we have to do. The contact action in Home Controller is going to return a view and render a complete web page. But remember, our objective is to just replace that form section element with this message. So instead of a view, what we really want to be returning is a partial view, and we'll create a new one called Contact Thanks. We've seen before that the leading underscore is just a convention that we use with partial views. So in the Home Views folder now, I'm going to add that view as a partial view, and it's just going to be an empty view because all I needed to do is to show the message from the view bag. And let's grab that markup from the contact page. Okay, so let's give this a try now. We can press Control F5 from the contact view to build and go right to this page. And then we'll send a test message and get our response. Now, if we view source, I can explain about that unobtrusive part. You might have expected a lot of JavaScript to be injected into this page to handle this AJAX request. But this library can do all of its work with just the external script and some data dash attributes applied to the form. So it's unobtrusive because it's not cluttering up the page with more inline scripts. This makes it less likely to conflict with other scripts on the page and more likely to degrade gracefully if JavaScript is disabled. One problem that some users might have with this is that the response is returned so quickly that it seems like perhaps nothing has happened at all. Now, part of that is because the contact action doesn't actually do any work with the message yet, so of course it executes very quickly. But when that's finally implemented, if it's still happening too quickly, you actually might want to delay the response and show a user a progress indicator for a second or two before updating the page. There are ways to do this with the Microsoft Ajax library. For example, we can display a progress icon in an onBegin JavaScript function and hide it in an onComplete. You can even set a loading element ID and a duration to accomplish this. However, these methods can sometimes be tricky and provide less flexibility. In the next video, we'll look at a different approach to partial page updates that gives us a lot more control. In this video, I'll show you how to make AJAX requests to an action using jQuery. We'll see how this offers us a bit more flexibility when managing the request lifecycle. Back in the contact view, I've gone ahead and commented out our first solution from the last video. Next, we're going to look at an alternative solution that features an enhanced loading image and which doesn't require any additional scripts like our previous example. You can see that I've kept the form section div, and I've also added an ID to the form element. I'm going to add another ID to text area, and we'll use these two IDs to reference these elements with jQuery. I'm also going to set up another script section because we want to make sure that the code we're about to write is executed after the jQuery library is loaded. So what we're going to do then is just write a handler for the form submission and use the jQuery post method to make an AJAX request to the contact action and update the page. I'm normally in the habit of using the document ready handler or this shortcut, but since we already know that the above elements are going to be loaded, it's really optional. So I'm going to write a submit handler for for the contact form now. And inside, we're going to use the post method shortcut for the AJAX method when we need to do a simple post without specifying a lot of options. For the URL, I could use Razor and do url.action, but even easier is to just leave it as an empty string. That will make it post back to the current URL. In older versions of IE, this wouldn't work, but should be a safe practice today. For data, I just need message, and then message.val. And then instead of passing a callback for the third parameter, the preferred way to do this today is to chain the done method here and define our callback that handles the response inside. And we can move these to separate lines to make it easier to read. So what we want this to do is to take that response and use it to replace the inner HTML of form section. And the HTML method here is equivalent to the insertion method.replace that we used in the Microsoft AJAX example. And it looks like I'm missing parens on my val method. And remember, I said we were also going to enhance this with a progress indicator image. So let's set that up now. The image is in the exercise files, chapter 7 in the start folder, and let's first drag it into the Solution Explorer, and then we can drag it into our view. I'll also give it an ID of progress and make it hidden by default. So then I'll reveal this image as soon as the form is submitted, and we don't need any code to hide it again because everything inside this div is going to disappear. But it would be nice to delay this replacement for a second or two so that we can actually see it. An easy way to do that is just to put this inside a function and then pass it to set timeout and delay it for 2000 milliseconds, say. Finally, to disable the normal synchronous action of the submit button, we'll want to return false at the end of the submit handler. So let's try out our new version of the AJAX contact form with Control F5 now. Test the form, and now we get this visual feedback that inspires a lot more confidence. So now we've seen two ways of making AJAX requests to controller actions. The first was easier to set up if you're more comfortable working with C# in a more configuration-based approach. The second required a bit more custom JavaScript, but afforded us greater flexibility when handling the response, and had the added benefit of not requiring an additional external script. In this video, I'm going to introduce you to some of the basic ideas behind Knockout. Knockout is an elegant JavaScript library that makes use of the model view model pattern to help make it easier to keep all our client-side elements and their properties in sync with one another. First, let's talk a little bit about the model view model pattern, or MVVM, and what that means for us when we're using ASP.NET MVC with Knockout. So MVVM stands for Model View Model, which is a slightly confusing abbreviation, but note the hyphens that separate the three components: model, view, and view model. And this is going to be a short explanation because the model is the same model that we've been talking about with MVC Architecture, a class that deals with persisted data for our application. And the view is the same view that we've been talking about all along. The view model, on the other hand, is a representation of data that we're going to work with on the client side for a given UI, and optionally, some operations that we might define for that data in UI. In Knockout, many of the view model elements are going to be represented by what are known as observables. These are objects that have the ability to notify other objects when they undergo changes, so that the other objects can make any necessary updates to their own state. Another way of putting that is that these objects can be observed by other objects that are dependent on them. As a simple example, imagine a text area for a Twitter message or a tweet, which has a limit of 140 characters. It's common to have a message that's dynamically updated to show the number of available characters remaining as the user types the tweet in real time, all on the client side. This is easy to do in Knockout, and I'll show you a similar simple example using our contact form before moving on to a more substantial one that builds out some additional functionality for our ATM in the next video. The first thing we need to do is grab the core Knockout script with NuGet. Right-click References, Manage NuGet Packages, and then search for Knockout.js and install. Let's drag this into our script section, and then we'll create another script element below where we'll be defining our view model. Our view model is going to be defined as a function, and I'm going to call it contact view model. A good habit to get into is, instead of worrying about scope in the value of this, just declare a variable like self and assign this to it. The first property I'm going to define is the message. And in a moment, I'm going to bind this to the text area message. This is going to be created with ko.observable. And if I wanted to initialize it with some value, I could pass it in here instead of the empty string that I'm going to pass. The next thing I'm going to set up is the message that tells the user how many characters are remaining. So let's say in my text area, I'm going to have an attribute for max length, which is 150. Again, it'll be nice to communicate that to the user, and it's even better if you can tell them exactly how many characters they have left as they're typing. So now we'll define another view model property called characters remaining. And this is going to be an instance of what's known as a computed observable, because we're going to be constructing this dynamically based on the current length of the message. So here's what this looks like. ko.computed, and then we'll be passing a function to build it, and that function's just going to return 150 minus self.message.length. Notice that to get or set the value of message, I need to call message like a function, similar to the way we use val in jQuery. And here's a place where using self pays off, because inside this function, this would have the wrong context. Although we could pass this in as a second parameter after the anonymous function to make it work. Okay, so just a few more pieces to set up. First, we have to bind the message observable to the text area's value, and we do that with the data bind attribute, data-bind, and we just have to give it value::message. Next, we need an element to bind the characters remaining property to, and we can just use a span for that. And since we're not dealing with an input value here that the user can edit, we use data-bind with text instead, and we give it text::characters remaining. Finally, to activate the bindings, we need to call ko, and we'll pass in an instance of our contact view model. So let's save and refresh our contact page and see what we have so far. So we'll just type a test message. And you can see that's not very impressive, but when I tab away from the text area, it does update the number of characters remaining. That's because, by default, the message observable is only going to notify observers when the value changes, and traditionally, that means when the field loses focus. But we can change this easily by adding another property to text area data bind here called value update. The default is change, but we can also use input, key up, key press, and after key down. I usually use after key down, but input is most reliable if a user has a reasonably up-to-date browser that supports the HTML5 input event, and it can even detect pasting into the text area. So let's try that. And let's also give the user a little more context for this number that's appearing by putting the text characters remaining after the number. So let's save and refresh. And now we get the desired effect, even with cut and paste. So we've begun to scratch the surface of what Knockout can do for us, and we've seen the ease with which we can set up dynamic behaviors and keep things in sync. In the next video, we'll build a simple grid with paging using Knockout for our checking account statement. In this video, I'll show you how to quickly implement a grid that includes pagination controls for displaying checking account transactions using Knockout. We're going to be adding functionality for the print statement option, so let's fill in the href value here using url.action to create a URL for the statement action in the checking account controller, and we'll pass it an ID parameter whose value will be the value of the checking account ID that's already in the view bag. And then we'll add a new action in the checking account controller. So statement will take an ID parameter the ID of the checking account, and we'll just grab that checking account from the DB set using the find method. And this time we can use our convenient transactions navigation property to quickly access all transactions for that account and pass them to the view as a list. So I've already prepared a corresponding statement view, and you can find that in the exercise files in Chapter 7 in the Start folder, and I'm just going to drag that into our checking account views folder and open it up. And you can see that it has a model directive specifying an IEnumerable of transaction. The table that will display the transactions has been assigned a few Bootstrap classes to make it a little prettier. Our transaction model is very simple, and we didn't bother with transaction dates, so I'm putting transaction ID here just so that we have at least 2 columns in the grid. In the footer of the table, we have pagination controls. Right now, they're just Bootstrap glyph icons for a left arrow and a right arrow, but we'll be binding their click events to behaviors in the view model and also displaying the current page number between them. Under the knockout library script, I have a single helper function just to format amounts with 2 decimal places. And then I have my view model followed by a call to apply bindings to activate it. The view model's properties are the following: an array containing all of the transactions that I want to display in the grid. This will be for the base set of transactions, not the current page's transactions. And we'll need to figure out a way to get those into my page as a JSON array. Next, we have a page size, which is the number of transactions to display on each page. Neither of these first 2 properties are going to change during the life cycle of the page, so we don't need to make them observables. Our first observable property is going to be the current page, because obviously when that changes, the grid needs to be updated, and we're initializing this to 1. By the way, if I did need to make transactions an observable, for instance, if the transactions in my grid were editable, I'd need to use ko.observableArray instead of just ko.observable. The list of current transactions will be a computed observable, since it's a subset of the base set of transactions that we calculate using the current page value. To get that subset, we just need a start index and an end index for the array, and then we can use the slice method to grab it. The start index is just the current page minus 1 multiplied by the page size. Note that since current page is an observable, we get its value by calling it like a function. The end index is just the start index plus the page size. Finally, we have 2 self-explanatory methods for moving the pager forward and backward. So from this point, all we need to do is bind properties and methods of the view model to the markup, and also produce a JSON array of transactions. But before we do that, I'm just going to add some seed data for one of my accounts so that we actually have a good number of transactions to look at. So in the exercise files, also in the Start folder under Chapter 7, there's a text file called seed data. I'm just going to copy these lines and paste them into my seed method, which is in the configuration class of the migrations folder. So whether or not there's an existing admin user, at the bottom of the seed method, I'm going to be adding a number of transactions for checking account ID 5, which is actually the checking account of the admin user. So if you're following along with your own version and you want to use this seed data, just make sure that checking account ID exists in your database. And to add these to your database, we just have to run update database from the package manager console. Okay, it looks like that worked, and let's go back to the view now. The next thing I want to do is embed my C# transaction list in the JavaScript here as a JSON array. And we can do this very easily using Razor and the JSON convert class. And this is in the newtonsoft.json namespace. We get this through a NuGet package that was already installed with this project template. So I'm going to use JSON convert.serializeObject and just pass it my model. We're also going to need to pass it an instance of JSON serializer settings. And the reason we need to do this is to tell it to ignore the circular references that we have between transactions and checking accounts, since each entity holds a reference to the other. And we can do that just by setting reference loop handling to reference loop handling.ignore. But one problem with this approach is that by default, Razor emits HTML encoded strings, and we want to make sure that our quotes in our JSON data aren't encoded as HTML entities. To fix that, we can just wrap this with html.raw. Notice that up here in my T-body, I only have one row. That's okay, because Knockout can use that as a template if we add a data bind to the T-body with a for each and give it our computed observable current transactions. And for the cells, I want to add data bind text with ID and formatted price, passing amount to that. For my pagination controls, we can do data bind click and just give it the name of a function, previous page and next page. And remember, we also want to show the current page number here. That's another data bind text with current page. And now we're ready to take our first look. I'm going to go over to the home page since I need to make sure that I'm clicking the link that passes the ID parameter, and start up. And now when I click print statement, I see my pageable grid. One thing that we haven't addressed is what happens when a user tries to go past the last page of results or before the first page of results. I don't want anyone going to page 4 or page 0 or -1, so let's fix that. For the left arrow, it's very simple. We can just use the visible binding with a test and say that we only want this to be visible if the current page is greater than 1. The right arrow is going to take a little more work because we have to figure out which page is the last page. We can calculate that as a property of our view model, and I'll put it after the current page. And we'll just have to take the length of the transactions array and divide by the page size. But if we have a remainder, we're going to want to round up so that we have an extra page for the last few transactions. So we'll wrap this in math.ceil to get the ceiling of that number. And then we can just do the same thing with visible and test whether current page is less than last page. And let's save and refresh and take another look. And there you go. We just built a decent looking grid with client-side paging from scratch, with Knockout's help, of course. In this video, I'm going to demonstrate how to deploy an application to Azure websites. Microsoft Azure provides scalable cloud platform and infrastructure services for basically any web or computing need you can think of, since they also offer Linux-based services in addition to Windows-based services. Like many providers, they do offer a free plan for websites, but charge small fees for database usage. As of the time this course is being recorded, they are offering some trial credits that you can use for a more complete experience. It's easy to set up an account, especially if you already have a Microsoft account, and once that's done, it's incredibly simple to deploy an application to Azure right from Visual Studio. Before we do that, I'm just going to make a few small changes to our project, since we want to make sure our code-first migrations are handled correctly. When we deploy to Azure, we're also going to set up an instance of SQL Server, and our web.config connection string is going to be updated for us automatically. We're going to allow automatic migrations to do all of the work of setting up the database for us, and we're also going to make sure our seed method is executed. We can leave the code for the creation of the admin user here, but let's remove or comment out the test transactions since we'll be simulating a deployment to a production environment where that data would probably be unwanted. Later in this chapter, we'll talk about deploying without automatic migrations, but as long as we're allowing them, we should also set automatic migrations data loss allowed to true. This will make things go a little more smoothly since we're not going to be using the package manager console in the production environment where we could do update database with the force option if necessary. Finally, we're going to remove these explicit migration scripts that we created back in Chapter 3, since we're going to allow automatic migrations to handle creating and updating the database And using a mix of explicit and automatic migrations can cause problems, or at the very least confusion when working in a team. So at this point, we're ready to publish and deploy. Right-click the project and select Publish. And for Publish Target, we're going to select Windows Azure Websites and then sign in. Next, I'm going to select New next to Websites. For the site name, we'll try automatedtellermachine.azurewebsites.net, since that's probably not taken already, and it isn't. Region can be West US, and we'll tell it to create a new database server. Let's make the username ATMWeb, and we'll give it a password. And then click Create. We'll want to leave web deploy as the publish method so that we can take advantage of the automatic deployment to Azure. We could also create a web deploy package that can be installed using a script, or deploy via FTP, or just publish the application to a directory on the file system, but we're going to stick with web deploy. So using these credentials that have just been set up for us, it's going to perform the deployment. We do want configuration mode release as opposed to debug, and we'll talk more about some of the effects that has at the end of this chapter. Under File Publish options, we can choose to remove any additional files at the destination that don't have corresponding files in our project. Pre-compiling is mostly going to affect the first person to use the site after it starts up, but if you click Configure, you have some options about how you want your assemblies organized and whether you want to be able to update views without recompiling, which is what this checkbox refers to. We can check Exclude Files from the App Data folder since we're not going to be using that SQL Server local DB file in production. Down here, checking this box is going to make sure our web.config is updated with the Azure SQL Server connection string that you see above. And we also want to check Execute Code First Migrations to trigger the necessary automatic migrations and so that it runs our seed method, the same way it does when we execute Update Database from the Package Manager console. Then we can click Publish, and once it's ready, it should just open the site in the browser for us. And let's log in as admin at MVC ATM to ensure that the database was created correctly and our seed method was executed. And everything looks good. There's a lot you can do in the management portal in Azure. You'll probably want to get SQL Server Management Studio to manage your database remotely, but you also have the option of making schema changes or running queries from within this portal. For future deployments, if you just need to change something in a view, you can use FTP without having to rebuild and restart your site. You'll just need to set up an FTP user by clicking Set up Deployment Credentials here on the dashboard page. But you can always just publish again and even preview the changes beforehand. So as you can see, deploying an application to Azure websites is incredibly simple, and once you're set up with an account, you can control the entire process from within Visual Studio. Another option for hosting your applications in the cloud is App Harbor. In this video, we'll talk about how to get set up with an account and deploy an application in a matter of minutes. We'll continue with our ATM project where we left off at the end of the last video. App Harbor is similar to other platform as a service providers like Heroku or Google's App Engine. It has a much simpler UI than Azure, and for many developers, it can feel a lot less bloated and overwhelming. You can do a lot with it for free, and even use a small amount of database storage until you need to scale up. Signing up is simple, and once you've set up an account, you can start by entering a name for your application. You can deploy from a variety of repository hosting services like Bitbucket, Codeplex, or GitHub, which by the way you can do with Azure as well. For our deployment, we're just going to use Git from our local machine. But before we do that, we'll want to make sure we're set up to use SQL Server, and that's actually an add-on that we'll have to install for this app. So let's click on Add-on Catalog here. Scroll to the bottom of this page and look for Shared Microsoft SQL Server, and then click the icon or the See More link. So under the Yocto plan, I can get 20 megabytes of storage. You won't go too far with that but it's perfect just to have something to play with. So let's go ahead and install that. Once that's done, click on it and then click Go to SQL Server up here. At the bottom of this page, we see the connection string, and it says, this is the connection string that will be injected by AppHarbor. So we won't need to change anything in our web.config to switch from SQL Server Local DB to this database that's provided by AppHarbor. However, we do need to tell it where we want it to be injected, and we can do that by setting the connection string alias to the name of our connection string in our web.config, which is default connection. So click Edit Database Configuration and set the alias. Entity Framework metadata doesn't apply for us because we're doing code first development, but I would want to set that if I had been using an entity data model with database first development. Multiple active result sets refers to executing multiple batches of statements with a single connection. Feel free to read up on that, but it won't affect what we're doing right now. One thing you won't get from AppHarbor is an offer to execute code-first migrations, but we can manually recreate what Azure was doing behind the scenes for us when it did so. In our application DB context class, I'm going to want to override a method called onModelCreating. You can find the code for this method in the exercise files in the Chapter 8 Start folder in this text file called onModelCreating. So I'm going to copy this and paste into our application DB context class. So this sets up a particular type of database initializer, specifically the migrate database to latest version type. There are a few other types you can use that will automatically drop and recreate the database, or only do so when the model changes, or only create the database if it doesn't already exist. But migrate to latest version is a good choice that you can use for your first deployment, as well as subsequent deployments after your model changes. The default implementation of this method does some setup work for ASP.NET identity models, so we need to make sure we call base.onModelCreating as well. This configuration class reference refers to the configuration class in the migrations folder, so you'll want to bring in that namespace if this is invalid for you. It's also possible to set this initializer in your application start method, but like application start, this method here will only be called once when the context is first referenced, and then it will cache the entire model for this context. A third way, which is the way it's done behind the scenes during an Azure deployment, is to configure it in web.config under the Entity Framework context element. You can see an example of this also in the Chapter 8 Start folder in Azure web.config. At the bottom, inside the Entity Framework element, we have the context element, and here we see a database initializer which references the migrate database to latest version type. But I find it to be a bit more pleasant to do this with code. And now we're ready to deploy, which we're going to do with Git. If you don't have Git installed already, go ahead and grab it from git-scm.com. I'm not going to say too much about Git now. You can find plenty of training resources on Git on lynda.com and elsewhere. So we're just going to do the simplest possible Git deployment to get set up on AppHarbor. So Git comes with command prompt support, GUI tools, and also Git Bash, which is a lightweight Unix bash shell, which I like to use for committing and pushing code. And since we're about to push code to AppHarbor, let's just make sure that these changes are saved. Okay. And now we can navigate to our solution directory. By the way, make sure there's only one solution in this directory. Otherwise, AppHarbor won't know what we're trying to deploy. Next, we'll type git init to initialize a new Git repository, and then git add dot to add all files to it. We won't get into a discussion of line endings now, but let me just say that in a real-world scenario, you'll want to set it up to ignore some of the Visual Studio files and generated folders. But for now, I just want to demonstrate the actual deployment. Next, we'll perform our first commit using git commit-m for message, and we'll just give it init for the initial commit message. One last thing we have to do before deployment is link this repository to our remote AppHarbor repository. And I can get that URL from my application page by clicking the repository URL button, which copies it to my clipboard. To be able to paste into Git Bash or the Windows command prompt, you'll need to right-click the title bar up here, select Properties, and then make sure Quick Edit Mode is selected. And then we'll use git remote add app harbor, which will be the repository name, and then right-click to paste the URL. And finally, we can do git push app harbor master to push our local master branch to the remote master branch of the app harbor repository. And here I'm just entering the password I used when I signed up for app harbor. And once that's done, if we go to our MVC ATM application page on app harbor and refresh, we can see that it's actually in the process of doing a build. And when it's done building, it's also going to run our unit tests. So when the build is complete, we see this unhappy looking icon, and the reason is because one of our tests has actually failed. And it tells us which one. It's the contact form says thanks test. And if we click that, it also shows us the error, which I think is some really nice visibility, although we might not be able to tell exactly what's going on without looking at the code. So let's do that. So in our unit test class, the problem is that we changed this contact form method to return a partial view result when we were experimenting with Ajax and partial page updates. So let's just change that to a partial view result here. We'll save and go back to git bash to add these changes, commit with a message of fixed unit test, and then push to app harbor again. Now, back on the status page, when this is finished building, we see the succeeded icon this time. And if we refresh, we see a link that says, go to your application. So let's click this to check it out. And if I can log in with my admin account, then I know that the database was updated properly and my seed method was executed. So with App Harbor, we've already seen a second way to quickly get your application deployed to a scalable cloud platform. Automatic code first migrations are a powerful tool, but there are scenarios where you'll want to be using only explicit code-based migrations. Continuing with our project where we left off in the last video, I'll now show you how to deploy an application that has automatic migrations disabled. We've had automatic migrations enabled most of the time while we've been developing our application. But let's imagine a scenario where we need to disable them. Automatic migrations aren't always perfect, and there will be edge cases where they simply won't work. Additionally, you may have to work with a team member or team leader who insists on reviewing all pending changes using either generated SQL scripts or code-based migrations. In the latter case, we'll need to make sure our explicit migrations are executed when we deploy. So I've set automatic migrations enabled to false in the configuration class. In my application DB context class, the database initializer that we set up for the first App Harbor deployment should perform an action that's equivalent to running update database from the package manager console, which remember will apply explicit migrations as well as automatic migrations before running the seed method. So since we've just disabled automatic migrations, we need to make sure that we have a complete set of explicit migrations that are up to date. And since we deleted the migrations that we had previously, we'll just need to add a single one that represents a complete initial migration from an empty database to the current state. The easiest way to do that is to reset our code first migrations by first deleting the migration history in the database. And I'm actually going to get there from the Solution Explorer by double-clicking the database file. So we can just click the migrations history table and press delete. And then we'll click Update Database. Then in the Package Manager console, we'll just do add-migration, and we'll call it initial create, just like the first one we generated. And then we get a code-based migration for the entire schema that you can review and edit if necessary before deploying. So we're actually ready for deployment now. But if we want to continue to develop and use this application locally afterward, we need to make sure that the migration we just created isn't ever executed on this database, since everything in it already exists. One way to get around that problem is to actually apply it with the up method commented out. So I just commented out everything in the up method, and this is going to allow it to be inserted in the migrations history table without actually being executed. So with that section commented out, I'll run update database, and then I'll go ahead and uncomment it so that it can be run during deployment. And now we're in a good position for deployment as well as continued development using explicit code first migrations. Just going to make sure this is saved. And then on App Harbor, I've already set up a new application called MVC ATM Explicit DB and installed the SQL Server add-on and set up my connection string alias. Let's go ahead and copy the repository URL. Then in Git Bash, I can just switch my remote repository to this one with the command git remote set-url app harbor and then the new repository URL. I'll also add and commit the latest changes, and we don't have to be concerned about removing items from the repository right now. I'm just going to go ahead and commit explicit migrations and then git push app harbor master. And when that's complete, I can refresh this page and wait for it to build and be deployed. Once it's finished and it's succeeded, we can refresh, and I'll have a link here for go to your application. If you see this Nginx page, it's just not quite ready, so wait a moment and refresh again. And now it looks like it's loading. So again, we'll log in as admin at MVC ATM to confirm that our database is up to date and our seed method executed. As you continue to make changes to your models, just make sure you keep adding explicit migrations. Otherwise, you'll get an error that tells you to add one or to turn on automatic migrations. And by the way, if we wanted to publish to Azure, it wouldn't matter in our current state if we uncheck this box, since our database initializer is going to take care of running our migrations. So that's basically all there is to it. Again, we want to try not to use a mix of automatic and explicit migrations, especially if we're working with multiple team members and sharing code with source control. But as you can see, whether you choose automatic or explicit migrations, deployment should be relatively painless. In this video, I'll show you how to automate changes to elements of your web.config file during a build that will be deployed. With web.config transformations, we have a useful tool for managing separate collections of settings for development and production environments, as well as any number of other environments that you need to consider. Some of what I'm about to show you was handled behind the scenes for us when we were deploying to Azure or App Harbor, namely the replacement of the connection string in our web.config with the production database connection string. This is also handled for us when we create a web deploy package, which is a zip file that can be installed with a command line tool called msdeploy to either a local or remote server running IIS. But whether we're deploying to IIS or to the cloud or just publishing to the file system, which we'll test in a moment, we can set up this kind of automated web config alteration ourselves because we might want to change more than just the database connection string. If we expand the web.config node in the Solution Explorer, we see two files, web.debug.config and web.release.config. These files describe changes that should be made to the base web.config file when building in debug or release mode. When publishing our project, we'll always have an opportunity to choose a configuration mode, and when deploying to App Harbor, our projects will always be built in release mode. But while running locally, we can switch between configurations using the drop-down below the main menu here. And by choosing Configuration Manager, I can also add a new one by choosing New from this drop-down. Say, for instance, I wanted to have a third environment called Test. I could add it here. Once I've created that, I can add yet another config transform by right-clicking web.config and choosing Add Config Transform. But what's inside these files exactly? If we look at web.debug.config first, there's some information in there, but just about everything is commented out. And although it's a good practice to explicitly define your debug settings here for clarity, I find that most developers who use transformations just use the base web.config for debug settings and then the release transform for their production settings. So let's take a look at that one. This is very similar to the debug version, but has one element that's not commented out. The structure of this file mirrors the structure of the main config file, but within the configuration element, we only need to define the subset of elements that we wish to add, remove, or edit. Let's uncomment this connection string element, which is similar to the one in our base web.config, but missing the provider name attribute and with two additional attributes that we don't see anywhere in the base web.config. The value of the locator attribute here indicates that this is going to have some effect on a connection string element that has a name attribute that matches this one, mydb. The value of the transform element indicates what that exact effect will be, namely transferring the attributes that are defined in this element, which just include a connection string. Of course, in our web.config, we don't have a connection string called mydb, but if we were to change this to default connection, then we could achieve the replacement of our connection string without the help of a publishing or deployment wizard. Inside of system.web, we have a compilation element that just has a transform attribute with a value of remove attributes. This indicates that we wish to remove the debug attribute from the compilation element, but leave all other attributes intact. If I want to remove more than one element, I can use a comma-separated list here. And the reason we didn't need a locator attribute here is that there is only one compilation element. Likewise below, there is only one custom errors element in the base web.config. And here, the transform value indicates that we want to just replace the one in the main config file with this one. Again, we would do this because we want detailed errors for local users, custom errors for remote users. And whatever attributes I have set in my base web.config, this will ensure that no matter what attributes are set in our base web.config, when I'm publishing in release mode, this is always going to be remote only. I'm just going to make sure that we are in release mode so we can test some of this in a moment. The values for locator and transform can get a lot more complicated than this. For example, match can work with XPath expressions and conditions, and transform can insert elements before or after other elements. Let's actually go ahead and add one more element using insert. So this will be an app settings. The app settings element is a child of configuration. And let's add a key for an SMTP server, which will be smtp.mvcatm.com. Now, this isn't defined in my web.config, and let's imagine that when running in debug mode, my code will never try to email anybody. So I could just say transform equals insert, and it will add this to my release configuration. If we save and right-click web.release.config, you can do preview transform and see exactly what the effects of this transformation will be. And when I publish, if I choose custom, and then we'll just call this file system, because I'm going to just create a compiled version of this application on the desktop in a folder called release, choose file system, make sure release configuration is selected, and then click publish. And then when we open that file up, we see our new connection string, our mail server setting, no attributes on our compilation element, and a replaced custom errors element. So while injection and replacement of connection strings by publishing wizards and deployment services is quite helpful, we've now seen how to take control of that ourselves with web.config transformations to manage settings across various environments. You can review all of the changes that we made to the project in this chapter in the final folder under Chapter 8 in the exercise files. It's now time for me to give you a second small assignment, which is basically to finish the remaining features of our application. However, in the exercise files in the Chapter 9 Start folder, I've already done some of the easy parts for you, which we'll go over in a minute, and which should give you a few hints on how to complete the rest. So imagine that after our recent deployments, we catch some flack from management and stakeholders for deploying an ATM that doesn't yet support withdrawing cash. And now we have to fix that as quickly as possible, along with the rest of the missing features. Here on the homepage, there are 3 options that we haven't implemented yet, and those are withdrawal, quick cash $100, and transfer funds. At this point, withdrawal and quick cash are trivial, so I've completed those for you. You can look over everything I've done at your leisure, but I'm going to go over one important piece of it before I leave you to work on the challenge, and that's checking for sufficient funds and manually adding an appropriate error to the model if necessary. So first, let's go over your assignment, and then I'll help you get started with a few hints. You're going to be implementing transfer funds. The form that will allow a user to do this will be pretty straightforward. All we need is an amount field and a to account number field, meaning the target or destination account for the transfer. And even though it might be nice to explicitly record this in the database as a transfer, we'll just add a transaction with a negative amount for the user initiating the transfer, and then another transaction with a positive opposite amount for the recipient of the transfer. You should also use Ajax to submit the form and handle the response. You can use the Microsoft Ajax library that we looked at, or pure jQuery Ajax, or any other library that you know of. Now, we've talked a lot about client-side and server-side validation, but not too much about other types of errors that we might need to handle. And there are 2 that I want you to consider during this exercise. The first is to handle the scenario where a user attempts to transfer more funds than they have available. You'll need to check the available balance and return an error in that case. The other one is an invalid destination account number. The user is going to be typing the account number for the transfer, so it will need to be checked to make sure it matches an existing account. Now, if you plan on using jQuery Ajax, which you should if you're comfortable doing so, don't just pass back a string or a status code that indicates success or failure in the response. Your response should be a partial view so you can let the built-in error handling do its magic if you need to redisplay the form. And then you shouldn't have to arrange any HTML for the result with JavaScript. So before you get started, let me show you one simple technique to manually add errors to the model when we check the balance and the destination account number. In the transaction controller, I've added an action to handle a withdrawal form submission. Inside this method, I'm checking the account balance here to see if there are enough available funds. If there aren't, all I have to do is call modelState.addModelError. And here, I'm associating the error message with the amount property. And if that error is added, modelState.isValid will be false, and we'll be returning the view so we can display the error. You don't have to associate an error with a specific property. If I wanted to, I could change this to an empty string, and it would display this error in the validation summary at the top of the form, instead of below the amount field, or wherever I put this razor code to emit the validation message. So you should expect to spend about 20 minutes on this challenge. When you've finished, or when 20 minutes are up, especially if you find yourself thrashing around on it without getting too far, go ahead and continue to the next video, where I'll present my solution. In this video, I'll present one possible solution to the previous challenge. Since this solution is just made up of a handful of components that you're already familiar with, I'm not going to make you watch me type all of the code and markup, and instead, I'm just going to show and explain what I've already implemented, which is in the exercise files in the Chapter 9 Final folder. First, in my transaction controller, I've added 2 transfer actions. The first takes a checking account ID and just displays a form for a user to initiate a transfer. The second handles the form submission, and the first thing it does is look up the current user's checking account so that it can check the balance. If the balance is less than the requested transfer amount, then an error is added to the model state, just like I showed you in the withdrawal action. Next, we'll look up the destination checking account. I'm using first or default here, so that it will return null if the checking account number isn't valid instead of throwing an exception. And if it does return null, we'll add an error with the appropriate message and associate it with the destination checking account number property. At this point, if the model state is valid, we'll add a debit transaction for the current user using the opposite of the requested transfer amount. Then we'll add a credit transaction for the destination account using the actual specified transfer amount. Finally, we'll call save changes and then let the checking account service update the balance for both accounts. So if the model state is valid, we'll be returning a partial view called transfer success, to which I'll pass our model called transfer. And that was just the parameter value for this method. And all transfer success does is confirm that we transferred the right amount to the right account using these model properties. Otherwise, if the model state wasn't valid, we'll just render transfer form again, which will display the errors. Now, if you're wondering why you have to pass this model to the transfer success partial view, but not to the transfer form partial view so that it can display errors, that's because transfer form is using HTML helpers, which will be able to find everything they need in the model state object. But in transfer success, since we're just accessing the model properties directly, we'll need to explicitly pass in the model. Let's go back to the transfer form partial view for a minute. This is a partial view because we're going to be updating with AJAX and, if necessary, replacing it completely, along with any error messages that we get if the transfer isn't accepted. You've seen almost everything in here before. I have my animated progress GIF down here that I'll be using. The submit button, however, has a class of cancel. This will disable the jQuery validation on submit, since I'm going to want to call it manually, and then only if it passes will I submit the form with AJAX. And that cancel class functionality isn't my creation. That's something that's built into the jQuery validate library. At the top, you can see the model directive specifies a transfer view model. So let's take a quick look at that. We have an amount and a checking account ID, two properties of a transaction that will be persisted in our database, and another that we'll use to build and validate a form and create a second transaction, but which won't be directly stored in the database itself, and that's the destination checking account number. Finally, in our main view, transfer, we render the partial view here and set up a script to handle submission. The reason that I'm binding the submit event to the document using the on method instead of using the submit method directly on the form is that when we submit this form with AJAX, if we need to update the form to show an error, that means that the transfer form element is going to be completely replaced by a new form element that won't have any event handlers defined on it. So instead of binding to this form element and rebinding after we replace it, we're delegating this event to the document itself and telling it to execute this handler for submit events that originate from an element with the ID transfer form. Inside, we'll set up a variable called the form that's a jQuery wrapped object for this, so we don't have to worry about the scope of this. And we'll trigger the jQuery validation by calling the valid method. If that returns true, we'll show the progress GIF and post to the current URL. For the data parameter, we can gather up the form elements using the serialize method. And then when this completes successfully, we'll just replace the entire form element with the response. And if you chained a fail method on there after done, then you're more thorough and conscientious than I am. But if there is, say, an HTTP error, we're probably not going to be able to help the user deal with it anyway, except to say, sorry, try again. But that would certainly be preferable to doing nothing. So let's give this a try. First, I'll try to transfer, say, $1 million to a non-existent account. And I get both error messages, insufficient funds and invalid destination account number. Next, I'll first check my balance and try to transfer all of it to the very first account we created. First, I'm going to remove this space at the end and the $ and the comma. Otherwise, the way we have things set up now, it's going to complain that that's not a valid decimal. And that first account was 4 zeros and then 1, 2, 3, 4, 5, 6. So you can go ahead and test this and then look in your database or look in the list view under checking account for further verification. One more word about our transfer actions. There are plenty of developers who would say that this is way too much logic for a controller, and in particular, that the controller shouldn't be responsible for handling any custom error logic like this. That's absolutely a good point. Personally, I'm comfortable putting these very basic checks into the controller because it makes adding the errors a bit more straightforward. And I think it does make sense to start with a working version like this and then refactor and think about moving some logic into a model or a service. For instance, we're now checking the available balance for withdrawal, quick cash, and transfer. So that would be a good candidate for a bit of logic to move elsewhere so that we're not repeating ourselves. So you got a little more practice with view models, partial views, link to entities, error handling, and invoking a controller action with AJAX from this simple implementation of a transfer of funds between two accounts. Before we wrap up, stay tuned for some thoughts on where to go from here with ASP.NET MVC.